We created Indigo Design App Builder to accelerate your app delivery with one app creation platform. Now your designers, developers, and product managers can all work in the same WYSIWYG cloud-based platform. No need to download anything, no heavy IDEs or third-party dependencies, reducing friction and costly errors, and providing customers and users with better apps faster. Indigo Design App Builder includes a rich layout system and complete toolbox of real UI components and tools. Designers simply drag and drop actual components to build a real app fast, without the requirement of a vector-based design. With an integrated design system, you can easily create custom themes matching your product's branding. Get started quickly with a sketch file or use a pre-built app template. Deliver apps faster to your customers. Try Indigo Design App Builder today.
Accepting payments simply and securely is what we do. For 20 years, we've helped hundreds of thousands of businesses simplify payments with products designed for an evolving world. Our integrated payments technology is active in 120 global markets, and our payment methods are trusted by tens of millions of consumers. So whatever your model, size, or sector, plug into PaySafe to grow your business with confidence. If your business doesn't stay current, it can lead to frustration on all sides. And your customers have an ever-changing array of ways to pay: cash, card, via a digital wallet, or a bank transfer. We accept over 70 different payment methods, online, in-store, or on the go. And with our wide menu of tools, applications, and banking relationships, you can provide your customers a secure, instant, and personalized payment experience. Plugging into PaySafe means connecting your customers to the ways they want to pay.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained.
Hershey Company is an organization that's driven to bring positive impact to the world. We have in excess of 80 iconic brands such as Reese, Kit Kat, Hershey's. Hershey's looking at how do we evaluate and manage the brands that we are delivering to ensure that they're profitable. So technology will help to bring a lot of that together, whether it's through how we actually process certain types of transactions, whether it's how we evaluate and manage the financial performance of certain brands or certain customers. The organization was faced with making a decision and moving directly to adopt SAP S/4HANA Central Finance. We see it already leading to quicker decision-making. We can do a lot of analysis on a brand, on a customer, on a specific cost center, as well as on vendor activity or customer activity. SAP was key to Hershey's overall success.
Smart IT е технологичното ядро за разработка и поддръжка на собствени комплексни бизнес решения на Management Financial Group. Български финансов холдинг в сферата на небанковите финансови услуги, опериращ в цяла Европа. Решенията, които Smart IT създава, подпомагат дигиталната трансформация на бизнеса. Днес звеното разполага с 130 специалисти, заети в разработката на ERP-системи, бизнес интелидженс, финтех платформи и още. Дейността на компаниите се разделя в 5 дивизионни направления. Дивизия Home Collected Credits има най-голям дял от групата с общ оборот от близо 140 милиона евро за последната година, с представителства в Централна и Източна Европа.
Казвам се Радостин Богдан. В екипа на Smart IT съм от 6 години. Нашите партньори имат нужда от решения, които позволяват лесно, бързо и гъвкаво да стартират и развиват бизнесите си. Гордеем се с най-мащабният ни проект – адаптивната финтех платформа SmartCheck, която им носи това конкурентно предимство.
Opportunity is everywhere. This could be fun. It's a door.
Ooh, it's doing a lot of kicking down there.
Waiting to be opened. Whatever your ambition, whatever your drive, whatever you're chasing,
Get ready, baby.
opportunity is everywhere. All you have to do to find it is get out. Here.
We're a pretty resilient species, and that's true now more than ever. We're finding new ways to do our jobs. We're calling on old skills. We're turning closets into offices and kitchen tables into 4-star restaurants. And we deserve digital experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. These adaptable apps rely on agile technology and mindsets to make the development process seamless. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
We are Musalasoft. Our office is the whole world, and in it there are 4 physical locations, Sofia, Skopje, Rusa and Burgas, where we get together again more and more often. 6 values which unite us from anywhere around the globe. 650 plus impeccable professionals, redefining the laws of teamwork. Over 1,000 projects for more than 200 clients from all over the world. And countless meetings for a beer or two. In the mountains, the seaside, with family, kids, friends, pets, you name it, we go for it. The heart of Musalasoft is where each one of us works and has fun, learns and shares knowledge. From collecting chocolates, gadgets, dragons, fishing hooks, pots and pans, fitness weights, and even pictures from Turbo Bubblegum, to having kids, serving cats, raising dogs, fish, birds, and going on adventures. Together, we enjoy teamwork. We are innovation. We make an impact. We create with passion, respect each other, and deliver quality. We are Musalasoft.
We are Ocado Technology, and we have been transforming online grocery through technology and automation. We build cutting-edge solutions using artificial intelligence, machine learning, data science, robotics, cloud technologies, and even Internet of Things. And all of this innovation is born out of 7 development centers across the whole Europe.
The scale of Ocado's ambition is fairly breathtaking. So there's a sense of opportunity to learn, but to contribute and actually make a difference.
We've come from almost nowhere, and we found ways to solve problems that no one else in the world has managed to solve.
What I found it's unique in the Ocado culture is this passion.
The ability to experiment, to check new things.
You have the autonomy to go out and look for different solutions, new solutions. That's what the whole place is about. How can we do it better?
we created Indigo Design App Builder to accelerate your app delivery with one app creation platform. Now your designers, developers, and product managers can all work in the same WYSIWYG cloud-based platform. No need to download anything, no heavy IDEs or third-party dependencies, reducing friction and costly errors, and providing customers and users with better apps faster. Indigo Design App Builder includes a rich layout system and complete toolbox of real UI components and tools. Designers simply drag and drop actual components to build a real app fast, without the requirement of a vector-based design. With an integrated design system, you can easily create custom themes matching your product's branding. Get started quickly with a sketch file or use a pre-built app template. Deliver apps faster to your customers. Try Indigo Design App Builder today.
Accepting payments simply and securely is what we do. For 20 years, we've helped hundreds of thousands of businesses simplify payments with products designed for an evolving world. Our integrated payments technology is active in 120 global markets, and our payment methods are trusted by tens of millions of consumers. So whatever your model, size, or sector, plug into PaySafe to grow your business with confidence. If your business doesn't stay current, it can lead to frustration on all sides. And your customers have an ever-changing array of ways to pay: cash, card, via a digital wallet, or a bank transfer. We accept over 70 different payment methods, online, in-store, or on the go. And with our wide menu of tools, applications, and banking relationships, you can provide your customers a secure, instant, and personalized payment experience. Plugging into PaySafe means connecting your customers to the ways they want to pay.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained.
The Hershey Company is an organization that's driven to bring positive impact to the world. We have in excess of 80 iconic brands such as Reese, Kit Kat, Hershey's. Hershey's looking at how do we evaluate and manage the brands that we are delivering to ensure that they're profitable. So technology will help to bring a lot of that together, whether it's through how we actually process certain types of transactions, whether it's how we evaluate and manage the financial performance of certain brands or certain customers. The organization was faced with making a decision and moving directly to adopt SAP S/4HANA Central Finance. We see it already leading to quicker decision making. We can do a lot of analysis on a brand, on a customer, on a specific cost center, as well as on vendor activity or customer activity. SAP was key to Hershey's overall success.
Smart IT.
Hello, and welcome to Ista 2021. This is Ista's 11th edition, and we're so excited to have you here. My name is Hristo Gergov, and for the past 6 years, I have had the incredible chance to be part of the team that is bringing this event to life. For the 11th time, we continue our mission to inspire and develop the IT community by bringing together popular speakers and IT professionals that are eager to learn. For 11 years, we have witnessed inspiring keynotes from experts in all industry and innovation areas. And for 11 years, people with passion for development, quality, automation, and innovation have had the opportunity to become part of the future of IT. So we would like to thank all the leading Bulgarian companies that are organizing Ista, all the companies that supported it, our partners, and last but not least, everyone that had the courage to join us as a speaker. Without you, we would not be able to create innovation, to share knowledge, and to bring people together who change the world. For this Ista, once again, we put all our effort into bringing you a diverse agenda. Some of our speakers are hands-on experts in certain tech stack, others are leading large-scale multinational organizations. They come from all over the world, USA, Brazil, Germany, and their technology domains includes areas such as cloud computing, Internet of Things, machine learning, big data, distributed systems, and so many more. Some of the talks today will help you do the first steps in acquiring a skill. Other will help you get a broader perspective on what it means to be a leader. And before we dive into the world of innovation, I would like to share a couple of technical details with you regarding the event. This year's were once again virtual. On one hand, it was quite challenging for us to provide the best experience. On the other hand, we see this as an opportunity to reach even more people like unlike ever before. Our agenda is separated into two streams. One of them is focused in software development, and the other one is with focus on QA. At the end of each session, you have the chance to ask questions to the speaker, so please don't hesitate to use the comment section for that. For our closing keynote, Robert Martin, also known as Uncle Bob, we have actually planned an extended 20-minute Q&A session. So if you have something in mind to ask one of the most recognizable speakers, teachers, best-selling authors in our industry, now is the time for that. The two tracks will be moderated separately. I will moderate the development track, and my colleague Milen Stefanov will be moderating the QA track. So enough boredom. What's left for me here is to introduce our first keynote speaker. He's a tech leader with quite a broad background in emerging technologies. His current role is to lead the Magenta Voice program of Deutsche Telekom. Actually, he was recognized as one of the top voice technologists last year. Most probably, most of you know that a very good understanding about technology is a must-have skill in order to be a leader in our industry. But sooner or later, you all figure out that it's not just about that. Today, our speaker will share his story about the art of leading product teams with empathy. So let's welcome Regu. Regu, we're so happy to have you here, and thank you much for joining. The stage is yours.
Thank you, Christoph, and thanks for the invitation to be here. I'm super thrilled to talk about some of my experiences. Today, we actually live in a world where technology is playing an increasing role in almost all aspects of life. And one of the things that differentiates us as humans and keeps the humanness in us when we deal with this world that is full of technology is actually empathy. You know, when you look at this Dilbert cartoon strip on the screen, which is can be seen as a sarcastic or ironic take on lack of empathy in leaders. It's actually frightening to look at the number of leaders who do not use empathy, which I believe is a hidden superpower, to actually lead teams towards higher productivity and towards better business outcomes. So what I want to do today is share my own journey of how, from being a software engineer towards a product leader, empathy has played a key role, and also some of the leadership principles and paradoxes that have helped me also in the work that we're doing at Deutsche Telekom. So if I, rewind to 15 years ago, that is me, Regu, sitting in a hackathon. So that time I was working at SAP, and this was a hackathon, a worldwide developer event in 2006, where you can see me sitting with a bunch of fellow developers and designers, really focused on writing code, building software, getting excited about technical stuff, learning new programming languages. So this was basically me back then, like a hardcore, nerdy software engineer. And back then, even though I had a lot of good managers that I had worked with, my view of management was quite a bit of these stereotypes of, managers who are standing over your shoulders, trying to micromanage, the ones who play politics all the time. So, management was kind of a very bad thing for me. This is what I had as, something that I would never want to do. I even told my boss, not too long ago, that I would never, ever become a manager. Now, fast forward 15 years, I'm leading the Magenta Voice Assistant product team at Deutsche Telekom. We have been on a very exciting journey of building a voice AI. And as you can see, I actually lead a fairly large product engineering team. In fact, it would be hard to see me in that big picture, which is where there's an icon showing me where I am. So, how did this transition happen? From someone who was very hands-on, hardcore, nerdy engineer, software engineer, to someone who is leading very large product teams. And this is where I want to talk about those values that have helped me, in this whole journey. I grew up in a middle-class family in South India, and my father used to have a moving job. So I used to move every 3 years. So I had I studied in 12 different schools throughout my career, throughout my early childhood days. And what you see on screen is actually a Hindu temple. So it's called the Big Temple. So it's a Shiva temple that's not too far from the place that I grew up. It was actually built by the Chola kings in the 10th century. And the most interesting thing about this temple is actually the tomb that you see on the top. So this is a single block of stone weighing 80 tons, standing at a height of 65 meters. Now think of how with primitive construction technologies, they would have managed to do something like this 1,000 years ago. There are a lot of conspiracy theories on how they managed to do it. I mean, one say that they built an inclined plane for 11 kilometers and pushed the stone with elephants. There's one which says they built concentric circles and moved the thing up. No matter how they managed to do it, for me, this is a remarkable feat of excellence. I mean, something that stands the test of time. I always think about the own software systems that we build. Are they going to really stand the test of time? But this is what I mean with excellence. So excellence has been a value that's been driving me throughout my childhood and also my career. Here's a personal story. I used to be shit scared of public speaking. Like things like what I'm doing today was never the norm when I was growing up, and also when I started my career. This was because as a kid, I used to stammer, and that was a big impediment that I had. And the only way I could get over that was by putting myself into things where I would talk and get over this uncomfortable feeling. So excellence has been something that has been really driving me throughout my life. So striving for excellence has been one of the most important values. Now, the second thing which has driven me a lot, and here I would like to start again a personal story, is this happened a couple of years ago. I was actually going through my LinkedIn feed and I saw this really great story of how the people at Lego had actually built a fully functional Bugatti Chiron with Lego blocks. And actually told this to my son, who was 9 years old at that time. I mean, he's crazy about cars and about Lego, so it was a killer combo. So he got curious and he wanted to know what this is all about. And then he figured out that there is a miniature model that he could build. So he even convinced his grandparents to give that as a birthday gift to him. And then, I mean, this is a Lego kit that's for 16 plus year olds. It's got 3,600 pieces with a 600-page manual. It took him 20 hours to build the entire piece. And during that, there was also a phase where he made a mistake. So he had to retrack 100 steps to build it again. But then the joy on his face when he finished that, that was priceless. I mean, this was curiosity at its best, combined with perseverance. And this is another thing that is also something that is very close to me, which is curiosity. I mean, I'm curious by nature, so I spend a lot of time reading stuff and I don't know certain things. As a developer, when there was a bug, I used to debug it until I would find the root cause and then also find the solution. So curiosity is again a value that has been really driving me in this pursuit of excellence. And like I said, combined with perseverance, that's a really killer combo. Now, moving on to the next value, where again, talking about stories, I'm pretty sure there are going to be a lot of Pixar fans in here. I'm a big time Pixar fan. I really love the way how Pixar combines technical advances in technology with really great emotional storytelling. I mean, who would have imagined of a rat that would cook, or a garbage collecting robot that goes across the universe, finding love, or an old man who uproots his entire home, trying to fulfill his wife's ambition. So, I mean, these are all stories that really stuck with me. And a few years ago, I had a chance to meet Greg Brando, the former CTO of Pixar. And I mean, I asked him this question. I mean, Pixar seems to be a company full of creative people, right? I mean, creative, very smart people. And when you put creative people in a room, I mean, how do they actually collaborate? I was intrigued by this thing of how would you put people in a room, so creative with all big size egos, how do they get to produce such amazing emotional stories? And he said something very profound that has stuck with me ever since. He said at Pixar, they check their egos out at the door. So whenever they have a meeting or when they're together, they always focus on what is right and not who is right. I mean, this is such a profound thing where getting off your ego and then really focusing on what is right, goes a far way in producing these really memorable movies that Pixar does. So the villain that we need to fight is not the Lotso bear, which, by the way, as a backstory, has a lot to do with empathy and emotion as to why Lotso became what he became at the end, but really our ego. So ego no-go has been something that's been also a value that has helped me, in my journey. So my own personal journey has been characterized by excellence, curiosity, and no ego. And this also helped me, move from my own software engineer background into product leader. And by the way, this talk is about leading product teams with empathy. So I would also now talk a bit about the story of what we've been doing with Magenta Voice Assistant and my journey for the last 3 years at Telecom. So for this, I need to go back to early 2019. If you had asked me during that time frame, how did I feel? I mean, I was new at Telecom, so I'd been with the company for 3 years. Before that, I'd spent most of my career working at SAP. It actually felt like jumping out of this plane without no parachutes. And the reason being, we had this passionate team that was working on building a German voice assistant and trying to launch a smart speaker product in the market. So, this started even a few years ago before I joined. So a team this was time when neither Alexa nor Google had launched in Germany. So we thought that there was a market. So we were really going after building a smart speaker. But at that time when I joined and I was asked to lead this team to launch the product to the market, it was quite clear that we were very far from that final product that we had to, bring to our customers. Now, this project had a lot of history. I mean, as you can see from some of these pictures back then, they were like really passionate and motivated people who were, working really hard to get this product to a state where we can ship it to our customers. And of course, there were lots and lots of pizzas. I mean, we had those amazing, times when people would be so motivated just to fix problems and get this out. And we had just been starting to, we had just started doing a customer trial, with the first MVP version of the product. And the feedback was not really great. I mean, we had really very low customer satisfaction. People didn't really like the product. This was a running joke, by the way, das habe ich gerade leider nicht verstanden, which means I did not understand you. So this was something the speaker was saying to people, and people really had to scream into the speaker to get something done out of it. And the team was really getting exhausted. They've been bearing very high management expectations, and they're sort of starting to lose the energy and the momentum. And I mean, here I was as a new kid in the block trying to motivate the team towards the finish line. And going back to that story of leading large teams and that picture that I showed you, I went to the teams and I remember we had an all hands where I put this up very big and said, keep calm and carry on. I really believe that as a leader, your biggest responsibility is actually to spread calm and motivate people towards continuing to run. And this was a message that was well perceived. There's also this great quote that I like from Bill McDermott, the former CEO of SAP, where he once said, optimism is the only free stimulus in the world. When the mood is positive, anything is possible. So that was the kind of thing that I was trying to get involved into the teams. But this was the easy part. I mean, we still had a big technical challenge that we had to face, fix all these challenges that I just said. And we embarked on something which I call as replacing the foundation, to basically rip and replace the entire technical stack that was powering the product, so the Telecom Smart Speaker and all the voice processing components. And this was something comparable to like you have built a house and now you're trying to replace the basement. And it was really difficult, but we figured out that this was the only way to do it. And we were basically, taking a big step. It was a bold one, but a very risky one because it could have failed. But at the end, we did manage to, replace the foundation. We got higher customer satisfaction scores in our customer trials. And then we finally launched the product in September 2019. And from that journey, starting from smart speakers, the Magenta Voice Assistant has actually grown and has now become available on multiple different touchpoints. So we are part of the TV remote controls, from the TV product of telecom, but also embedded into the TV experience, as well as on multiple mobile apps like customer care, smart home. So this journey has been really exciting, and as you can see, it was not easy. It was quite challenging. And I want to now talk about the leadership principles that helped me, get through this really tough journey which we had. And that's something I can really look back at now, say with pride, that it was really worth and, spending all that energy and effort and the passion that we were as a team, doing on Magenta Voice Assistant. Now, the first thing I talked about excellence as my own value, but as a leader, you definitely have to recognize excellence in others, right? I mean, with his own story of how passionate and motivated the team was, working towards sometimes seemingly impossible milestones, I had to be there with the team, appreciating what they were doing. And this appreciation can come in different forms. It can be in pre-COVID days, it would be a small pat in the back when you met people face to face. It could be a small email, to an individual or to the entire team, recognizing the work which they've done. So recognizing excellence is actually something really crucial. I mean, especially when you're working on problems which are, let's say, high magnitude topics to fix. And just to be clear, being excellent doesn't mean that you don't fail. I mean, failure and experimentation and learning from mistakes is all part of the journey. And as a leader, you should also be willing to accept that you're going to have failures, you're going to have setbacks, and this is all part of the journey of becoming excellent overall. But again, if this was all easy, everybody would be doing it. Why is it so hard? Because there are also these paradoxes of, when you think of recognizing excellence, when do you focus on the individual identity, meaning individual people, versus when do you focus on the collective identity, So this is something that you need to alternate between. It's not easy, which is why it's all situational, but keep in mind that recognizing excellence also has this paradox attached to it, that sometimes you don't want to put a lot of limelight on individual people, which might then, alienate others within the team. But at the same time, you always don't want to put your limelight on the team collectively, because then you have people, and people are passionate about things, and they really appreciate getting individual recognition. So this is a paradox that you need to be aware of on, when to shine light on individual versus the team. The second leadership principle that has also been something that I really follow and is part of the way that I work, is taking genuine care of your team. I mean, especially in these high-profile situations when the pressure is so high, you definitely have to be there with your teams and then taking care of your teams. And again, taking care of your team doesn't mean being nice and being, lax with them. You definitely have to set high, ambitious goals, which would motivate the team. At the same time, when there are setbacks, when there are, so you really need to be there, making sure that, you are taking care of the team. And again, going back to that paradox of what does it mean is, when do you support the team and when do you confront them, right? Support, again, going back to this topic of leading with empathy, you definitely need to be genuinely, showing support for your team and the people who are working in your team. But at the same time, when you see behavior that is not acceptable, you definitely have to confront. So alternating between confrontation and support is actually the paradox that you need to deal with when you really take genuine care of your team. And the third thing, again, going back to this topic of leading product teams with empathy, is actually, I believe, the most difficult one is as a leader to show vulnerability. So being vulnerable. Being vulnerable means you need to accept and be open with your teams that you don't have all the answers. For someone like me who's an introvert, asking for help from others doesn't come natural. I mean, I'm used to figuring out things myself or within our team. So we are kind of always working closely. But in our journey of launching the smart speaker, I realized that I had to go out and get support from a lot of other teams. I mean, especially in large organizations, you definitely need the help from others and be open in asking for help. And that means you need to be vulnerable and be open about the challenges that you have and openly talk about things where you definitely need help. This requires a lot of trust to be built. I mean, I'm also one who believes in trust by default. So building up trust and getting more vulnerable about things and how the challenges are and all the critical things that you're facing goes a long way. One of the things that I also want to share is last year, being part of this whole being vulnerable thing, I also decided to share my 360 feedback with my direct team. So this is one where I had all positives and negatives written about me, and it took a lot of being vulnerable to get over to share this with the team, because being open also then brought back the team that they trusted in me being so open, that it also helped me to improve certain things which I want to improve. So this is something which I believe is tough, but it goes a long way in leading product teams with empathy. Again, the paradox here is, when are you patient with the team and when do you accelerate? So the urgency versus patience is something that you need to keep in mind as a leader, and then alternate between the two. So to recap, at least the principles that have helped me, the leadership principles is recognize excellence, take genuine care of a team, and be vulnerable. So with that, and by the way, one more thing, I've talked about and I've recapped a lot of these principles, but for people who come from command and control, micromanaging, and those kind of traditional leadership behavior, there's one thing that I would advise and ask you to take out of this talk, that is letting it go. So, you don't need to know everything. Trust your team and make your team autonomous, empower them, give them all the support, but then get out of their way. There's also, aligns with the agile principles of, removing impediments for the team and then getting out of the way. So if there's one thing that I want you to take out of this talk today, that would be, let it go. Thank you so much.
Thank you so much, Raghu. This was so inspiring. Unfortunately, we don't have time for questions, so I would like to thank you on behalf of the Ista team and our attendees. Appreciated the fact that you joined, and hope that you join us again in the future. Also coming up next is a 5-minute break before our next talk in the agenda.
Yeah. Thanks a lot, Ista. And if there are questions, feel free to connect with me on LinkedIn, and happy to answer questions even later. So thanks a lot for that opportunity.
Thank you.
Е технологичното ядро за разработка и поддръжка на собствени комплексни бизнес решения на Management Financial Group. Български финансов холдинг в сферата на небанковите финансови услуги, опериращ в цяла Европа. Решенията, които Smart IT създава, подпомагат дигиталната трансформация на бизнеса. Днес звеното разполага с 130 специалисти, заети в разработката на ERP-системи, бизнес интелидженс, финтех платформи и още. Дейността на компаниите се разделя в 5 дивизионни направления. Дивизия Home Collected Credits има най-голям дял от групата с общ оборот от близо 140 милиона евро за последната година, с представителства в Централна и Източна Европа.
Казвам се Радостин Богданов. В екипа на Smart IT съм от 6 години. Нашите партньори имат нужда от решения, които позволяват лесно, бързо и гъвкаво да стартират и развиват бизнесите си. Гордеем се с най-мащабният ни проект – адаптивната финтех платформа SmartCheck, която им носи това конкурентно предимство.
Opportunity is everywhere. This could be fun. It's a door.
It's doing a lot of kicking down there.
Waiting to be opened. Whatever your ambition, whatever your drive, whatever you're chasing, opportunity is everywhere. All you have to do to find it is get out. Here.
We're a pretty resilient species, and that's true now more than ever. We're finding new ways to do our jobs. We're calling on old skills. We're turning closets into offices and kitchen tables into four-star restaurants. And we deserve digital experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. These adaptable apps rely on agile technology and mindsets to make the development process seamless. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
We are Musalasoft. Our office is the whole world, and in it there are 4 physical locations, Sofia, Skopje, Rusa and Burgas, where we get together again more and more often. 6 values which unite us from anywhere around the globe. 650 plus impeccable professionals, redefining the laws of teamwork. Over 1,000 projects for more than 200 clients from all over the world. And countless meetings for a beer or two. In the mountains, the seaside, with family, kids, friends, pets, you name it, we go for it. The heart of Musalasoft is where each one of us works and has fun, learns and shares knowledge. From collecting chocolates, gadgets, dragons, fishing hooks, pots and pans, fitness weights, and even pictures from Turbo Bubblegum, to having kids, serving cats, raising dogs, fish, birds, and going on adventures. Together, we enjoy teamwork. We are innovation. We make an impact. We create with passion, respect each other, and deliver quality. We are Musalasoft.
We are Ocado Technology, and we have been transforming online grocery through technology and automation. We build cutting-edge solutions using artificial intelligence, machine learning, data science, robotics, cloud technologies, and even Internet of Things. And all of this innovation is born out of 7 development centers across the whole Europe.
The scale of Ocado's ambition is fairly breathtaking. So there's a sense of opportunity to learn, but to
Hello everyone, my name is Milan Stefanov.
welcome back to the development track of Ista 2021. Our next speaker, his name is Alex Lay. He's a director at VMware with focus on application modernization. He previously was involved in Cloud Foundry and Open Service Broker API. Today, he will be telling us about executable strategic roadmaps for app modernization. Hello, Alex, and thanks for having you here. The stage is yours.
Great, thank you for the introduction, and yeah, very happy to be here today. Glad to be here talking about executable strategic roadmaps. Like you mentioned, I've been working in the app modernization space now for several years, helping really VMware customers with their journey from some monolithic systems that sit in the deepest, darkest corners of data centers through to helping thinking about taking large portfolios of applications on a hybrid cloud, multi-cloud modernization journey. And so I'm going to tell you some of the methods and some of the tools and techniques that we've developed to help our customers go on this journey. And I think will be really valuable for some of you, especially anyone who's got software that's older than 3-4 years old. You're going to be looking to modernize to better leverage the latest and greatest cloud technologies. And you need a way to explain this to your colleagues and counterparts. So that's the focus of today's talk. So starting off with, this is a favorite cartoon of ours, and if you've seen myself or my colleagues present, you probably have came across this one before, but this really well encapsulates the typical enterprise journey to cloud, right? You've got legacy software that's a massive beast in the organization. You've got cloud architects that are trying to figure out how this can fit into a completely different paradigm. You've got the legacy sysadmin still dealing with all of the challenges that the application faces with, using all of your storage on-prem or constantly falling over because it's getting too much traffic. And then, you've only got a handful of people who are the now senior developers that understand what this software actually does, and they were here when it was originally written. And so things that we often hear are, challenges like we need to get 200 applications running in production on the cloud in the next few months, or I'd like to get a work stream per business unit set up so that we can have all 25 business units working on cloud all at the same time. Oh, and by the way, we've never done this before, but we need this to happen right now. Or another common one of, hey, I've got 4,500 applications. They need to all go on a cloud journey because we want to shut down our data center. But I don't have an idea of where to get started or how to get started. It could also be the monolith case where we've got a massive piece of very important software that's just struggling to meet the performance needs of the organization. Great examples in some of the videos that we saw in the break around the need for adapting to the current market situation. If we look at COVID, there had to be a massive change in business models for many organizations, and how quickly could they adapt their software was the real test of whether or not they were going to be successful in their marketplace. And finally, I hear more than often of, we started modernizing and maybe we got a bit distracted, and it's taken us, we've done this much work in the last year, and we say, well, what's in production? And often we hear back, well, nothing's in production yet, but we're testing out Kubernetes, or we're testing out this new AWS service. And until the software's in production, I firmly believe that you haven't delivered any value to your users. So with that in mind, often the first thing that we do when we've been tasked with move 5,000 applications to cloud in the next 12 months is people will go and say, well, what's available? What's out there? And we get all of the best architects together who will start going, yeah, we really could use a service mesh. Or wouldn't it be great if we hosted our own Kubernetes? Oh no, maybe we should use an AWS one. Let's do a proof of concept to see the difference between a hosted version and a one that we run ourselves. Oh, and do we need to look at how we do compatibility between certain API gateways and existing infrastructure we have on-prem? And often this looks something like this. Your architects start going crazy after about 6 months of running around in circles, figuring out how to plug all this technology together. And then we say, oh, we forgot about the applications. So we go off and do an analysis phase, and someone wants a report that explains every single application that you've got and tells you exactly what's going to happen with it, and exactly how within 2 years all of those are going to move, and in what order they're going to move. And you get this massive roadmap, and that's kind of like 6 months later. So you're now 12 months down the line, you've made no progress against your original goal. And then you have a plan, and then your management team come along and say, yeah, give me that in a Gantt chart, please. Give me that in a timeline, commit to that. I'm going to take that to my leadership team and tell them that this is all going to be done in 2 years' time, and we'll all be on the cloud, and that's going to be great. And in reality, we know that that's not likely to get the outcomes the business is looking for. And also from a technology standpoint, there's so much unknown with app modernization. Like I mentioned, the developers have probably left the organization. You might have poor documentation. Maybe you're using third-party software in combination. And then if you look at the infrastructure it's running on is complex, and this is no easy task. And if you do it this way, you're setting yourself up to fail. And I love this Twitter thread from Gianna Basto, who's a product leader, CEO at ProductPad, and she's got a great thread. Recommend reading the whole thing. I've just taken my favorite tweets from this. And she says that most roadmaps are setting their product teams up to fail because most roadmaps still follow this timeline format. And maybe you're saying, hey, my agile team doesn't do that. We work agile, we work in sprints, or we do iterations. But when we come to looking at application modernization, and especially larger cloud migration programs or cloud modernization programs, what we still see is they still use this timeline format more often than not. This looks something like this, right? Where you have due dates and duration, you have all the tasks in the timeline, and you can imagine this is filled up with different applications. You might have your corporate website, you might have your HR systems, and everything we plotted out, and it will say exactly what's going to happen. What this means is like Jana calls out, is there's a whole lot of assumptions in this timeline that you're committing to. You haven't actually tested this out. This is all paper-based theory. It looks good in the boxes and lines diagram, but you haven't actually put this to the test. And then also it means that you're committing to something that's hard to change. And just like the agile mindset, right? Like we might not want to modernize an application that we said we did 6 months ago, because maybe something's changed. Maybe there's a more important area of the business that needs to have faster time to market. Or we've seen that there's a new regulation that came in that means we need to patch and keep secure certain parts of our application estate in a different way than we did before. And so if we're committing to a timeline-based roadmap, that means that we can't really adapt it easily, and it causes a lot of friction with the expectations you've set in the organization. So we want a way that allows us to change the plans and adjust our modernization priorities back to what the business is demanding and ultimately what your customers are demanding. So how do we do this, right? And going back to the premise of this talk, right, we think about executable strategic roadmaps. And the first point being executable. Well, what do I mean by executable? Well, think of it this way. You can get started immediately and make progress. So what we want to see is that as a development team or as a team of teams, that you can pick up this roadmap and you can look at it and understand, okay, I have a way of getting started. I understand what I'm going to be doing. I've got some repeatable patterns that I can apply here. I know the landing zone potentially of where the application is going to go, and we can start making progress from day one. We want them to be strategic because it needs to align to the business priorities and strategies. And we need it in a roadmap so we can communicate our direction, focus, and the why. So we can tell this great story of we're going to modernize these applications because it helps us deliver better customer outcomes through more frequent releases to production. It's going to increase stability for these key customer types. And our developers can then also understand, well, how do I get started with this, right? Like I have all the things I need to get going and actually start changing the application or doing the work to it to modernize it. Okay, so if we agree that this is a good way to go, well, we can't have a roadmap that has an answer for all 500 applications in your portfolio. We need to prioritize. And the way that we like to think about prioritizing is creating a decisioning model. So you can take all the applications and pour it into this model. And what it should start to give you at the end of this is a prioritization. And it will tell you these applications are worth spending more time on, right? Based on some factors, which I'll talk through in a sec, you'll see that certain applications are going to be more interesting for us to spend time on, and it will give us a better chance of impacting against the mission. So this often falls into two buckets. We often see there's a technical feasibility. So based on the application, how much of a fit is it for modernization and how much effort will that be? Is it a mainframe application and no one in the organization knows anything about it? That's going to be very hard versus an application that's maybe a piece of Java software that was built in the last 10 years, right? That's often easier to get started on a modernization journey. Then when you think about business value, you're going to be looking at things like time to market, or is it going to impact the ability to deliver some new functionality to customers, or change the way that you operate the software that saves you money. And so a couple of examples here. both on the technical feasibility, we might look at, I'm going to show you this way of analyzing application source code in a minute. Then we might look at resiliency, we might look at dependencies the software has, and then from the business side, the strategic value, maybe the delivery velocity. But what you want to do is build a model that's right for your organization, right? So when you're looking at what's important from a technology perspective, you put those factors in, and that might be different to these, right? It might be to do with like scalability, cost saving, license costs, and same from the business value. You need to map this back onto your organization. But these are just some things to get you thinking and get started. And at the end of this, what we want to be able to do is put this into a strategic monetization prioritization chart. This is going to help guide us where to put our focus. I'm going to show you an example of this in the talk as well. Okay, so the first step we think of is building this scoring algorithm and putting some weightings to it. And so to actually implement the model in a more scientific way, we've developed a lightweight way of classifying and putting value to those different attributes. So we might say in this simple example, we're going to put 50% of the weighting towards the business score, and we'll put 50% of the weighting towards the technology score. Within the business score for strategic value, we're going to look at things like, is the app used by customers? Is it tied to addressing a compliance or security issue? We might look at delivery velocity, which would include how many developers are dedicated to maintaining the app, how many times you've released features in the last year. And these are all indicators whether it's got a healthy delivery velocity. And we'll also be able to prioritize on what do we want in the future? Like, does this application need to go faster? And you can put this into this model. On the technology side, you might weight this towards resiliency, which would have, like, does this impact our ability to meet a customer service level agreement? Or dependency, like, do lots of other applications depend on this application? And if we could turn it into an application that, say, provides APIs, for example, would that mean that that whole ecosystem gets much more benefit from the application? So again, customize this, assign a weight, become a bit more scientific is my advice. This helps you explain why you've made decisions. I see organizations often fall into the trap of picking their favorite application and getting stuck on that. So avoid this, get a bit more scientific. You can model this on a whole business, on a business unit basis, on a product basis, but it really helps you come back to explain your decisions. And as you'll see later, you can adjust this model based on your new priorities and reorder your roadmap. So again, I'll show you an example of that later in the talk. So one thing I did want to introduce, I don't normally like to talk about tools too much, but as this is a developer track, I think this might be quite fun for some of you. So at VMware, we've developed a tool called Cloud Suitability Analyzer. We've just open sourced it recently, so you can try this in your organization. It picks out something like 1,900 anti-patterns for modernization. And so what this does is it runs against the source code of your applications, and it tells you things around how hard it might be to move this into a cloud-friendly environment, or how container-friendly or container-ready this application is. And it gives you insights into the portfolio. It tells you what the main APIs, languages are used, and other things. And this effectively helps you make accelerated decisions. And also, going back to the executable point, as you'll see in a second, it shows the developers line by line which lines of code are going to cause them problems, or which libraries are causing them issues. And this will start to tell them if there's out support Java, file system dependencies, legacy frameworks. And it's super accelerates that first pass of technical analysis and allows you then to go and have smarter conversations with the application teams that own those apps. And so this is available on GitHub, VMware Tanzu Cloud Suitability Analyzer. So go check it out, give it a try. But how do you run this, right? It's quite straightforward. It's a command line based application. And so it's all self-contained, runs 100% offline, which is great if you're running in an air-gapped environment, or you don't want to expose your source code to kind of outside interference, let's say. So you download this one, put all of your source code in a folder, and then you can run Cloud Suitability Analyzer over this. What that generates is allows you to bring up this nice UI, and you can start to explore the different applications. You can see how many high priority issues there are. You can see the line of code that's causing the issue, and you can start to then understand what we would call recipes. So you might have a common solution so that when engineers in your team come across this problem in the future, let's say when they're going and containerizing their application or putting it on Kubernetes, then they can follow the recipe or follow an automated tool that fixes that issue. It's also customizable for your apps, so that we know that not every application, you might use different technologies, right? You might have PHP applications, you might use Node.js, you might use .NET. So you can actually extend the tool and write your own rules. So an example here is a Java-based rule that's going to look for a certain pattern in the application source code, and then it's going to give you the advice of what to do. And so you can write your own rules and start to extend the tool. You can also write your own models for scoring. And so you'll have noticed on here, you'll see that each application is given a score. We've got a scoring algorithm that we've made that's kind of the default one. You can also start to build your own scoring algorithm that would imply the technical complexity or technical feasibility of doing something with this application in terms of modernization. Great. So going back to our scoring algorithm, like we've maybe went off and talked to some of our business stakeholders, we've talked to the product owners, and they've came back to us with some information about the application, right? Like they've answered our question and we'll be able to assign points based on certain factors. So again, on the point scoring, you might have a graduated scale that you might apply to the points, right? You might go high, medium, and low, and maybe medium is 20 points, 30 points, etc. And you can assign that to the applications. So you apply the scoring, and so this is telling us here that the application isn't used directly by customers, but it is very critical for compliance for compliance use cases. Then on the technical side, we've seen that the Cloud Suitability Analyzer score has told us it's very low effort. So that means it's in a good condition. It'd be quite easy to get it running in a more modern environment. And maybe also it's easier to make changes to the application. And then maybe we've done some research by talking to teams or looking at your observability stack and have seen that actually this application mostly meets its SLAs, but there's been a lot of production issues, and maybe there's an opportunity to improve resiliency in the application. So putting this all together is interesting because it gives us two different perspectives to look at. And then when you put this combined score based on, say, a 50-50 weighting of this, what it's telling us is this application's got a 48, right? And what you can then start to do is compare this against other applications. So the higher the score, the more the opportunity that we have here. And so when you put this together, we often find that refer to this as looking for the golden nuggets in the portfolio. So this is a 2x2 here. And this is a super easy way to start classifying the application. So on this axis, we've got the technical feasibility. So that's like, is it very feasible? Is it very simple? And is there high business value, right? So is the business value low, or is the business value high, or business value low? And so when we start to plot these into a chart, what you can see is that there's a group of applications here that's high value and highly feasible. And this is in this section. And then you've got some that are high value but low feasibility. So these are maybe the ones that your customers really care about, but it's going to be really, really hard to change the technology. And then over here, we've got ones that are low value, but very technically feasible. So maybe this is where you might not want to invest too much in them, but hey, if you could get them running on a more modern platform, that might save you a lot of time, a lot of money in terms of the operational tasks that you might do. It might make it simpler for your developers, so you get more highly productive developers. And taking a cross-section of these applications will allow you to start to focus in on where there might be value for the organization. Okay, so the next concept of once you've started to look at which applications are the ones that are likely to be high value and highly feasible and give you a good chance of having an impact against your objectives, you might want to start thinking about building archetypes. And this is an interesting concept of categorizing applications based on similar patterns and similar constructs. And so in this example, what you can see are these different clusters of similar applications based on certain criteria. So we might understand what the footprint of a pattern is within the portfolio. So we might see that, hey, there's quite a lot of applications that are Java applications that have single sign-on capabilities. Right, and that might be interesting for us, or we might say that we have lots of finance applications that are all batch. And we can start to give them this characteristics. And so what we can then think about is if we solve a pattern for one of these applications, what's the knock-on effect of that, so to speak? So if we solve it for this application, does it mean we solve it for all of these? And you can think of that as an accelerator. So you've solved it once based on a pattern, and then you can estimate the impact that's going to have. And you can then start to think about, well, is this a good investment, right? Like it's going to take us a fair amount of time to make this one change, but once we've solved it, we know that it's applicable to 30% of our portfolio. And so that's what we think of is these accelerators, and doing it in a smart way rather than just a timeline where you commit to everything. And just a couple of examples here of what these might look like, right? You might group them by technology type. You might group them also, like I mentioned, by line of business type. It really depends on what's going to be meaningful for your teams and organization. Okay, so next question we often get asked is, great, well, we know the applications that are valuable. We know the ones that are feasible. We've got an idea of where we could start to create patterns from based on those archetypes. But where does this go? Like, where do the developers actually land the application based on what criteria? And we find that if you don't give the team the guardrails, we can go back to that picture we've seen at the start of everyone looking at the CNCF catalog and kind of going crazy. So we believe in giving the developers and the teams that will be doing the modernization guidance on what we call landing zones. Okay, so we've put the application portfolio through the decisioning model. We then might start to say that based on the application's technical feasibility, based on some technical characteristics like this application is already containerized, right? This application is off-the-shelf software, or this application has more stateful, complex things. We might start to look at a solution like a container API landing zone. And then we can think, well, what do these applications need if they're running on this container API? Well, maybe they need API gateways, maybe they need logging metrics, single sign-on. And we can start to build the right platform that's going to meet the needs of the applications that we're going to prioritize. You might start to look at more adventurous refactoring for some applications. So this is often the applications that need a higher rate of change, or we need to get them in a place where, when the product team decide that we need to rapidly change how the product works, that these applications can react a lot quicker. This might be new applications, it might be 12-factor applications, Spring applications, more modern .NET Core applications, and these might run on an applications API. So this might be kind of like, think of Amazon Elastic Beanstalk, it might be more of a serverless type platform, could also be a platform like Cloud Foundry, kind of any platform as a service could be a good landing zone for reducing the amount of time developers need to think about infrastructure. But for some applications, they don't change very often, or maybe they have some real complex dependencies on the infrastructure, or we need to keep them very close to the native landing zone. Maybe we'll just rehost those applications, right? And this is the kind of UMS for maybe less, or move it from A to B, not fundamentally changing things, but this could help us with reducing costs, making smarter use of our infrastructure footprint, and is an option that we should all consider. So having a model like this, customize it for your teams, give them some guidance on the landing zone based on what they're trying to achieve. And then think about whether it's worth investing in refactoring, how much effort is to move it onto a new abstraction level like Kubernetes, or whether or not it's not really worth investing in too much. Finally, we put this together into a executable strategic roadmap. What we see here is this is the grand plan. So this is the alternative to a timeline-based roadmap. So on the top, you can see kind of the outcomes we're trying to drive towards, which is the first phase. We're thinking, let's create the recipes, create the patterns. We'll take a cross-section of different teams. We'll take a section of different recommended landing zones. So, hey, we're going to do some where we're going to re-platform, some where we refactor. And after we've done this, we'll be able to execute much quicker on the next round of applications. So then we might tackle the high priority and highly technical feasible applications. Then we might scale to more complex apps. And by the end of this, maybe customers get features 10 times faster on the most used applications, right? Which might be the big objective we're trying to achieve as a company. But what's important here, and what we need to communicate to our stakeholders, is that if you look at what we're saying down here, which is higher certainty will be earlier on in the roadmap, right? So we're quite certain that these applications are the ones to start with. Then we think if these applications, if we get the results we expected, potentially this application group is good to go next. But this might change, and you might want to come back to your decision model and rethink the priorities based on what you learn from the modernizations you do, right? Like we expected by doing XYZ changes that Super API was going to be 10 times faster, but actually it's only 5 times faster. So does that affect our calculations? Do we need to change our model or change our assessment methodology? And that might mean the roadmap changes. But that's not a bad thing, and that's the whole purpose of executable strategic roadmaps, is that you can get started quickly, you can map this back to your priorities, and you can communicate what you're doing, why you're doing it to your stakeholders. So I think that's all I had to show you. We will be launching some tools to make this a bit easier for you. We're going to be hopefully putting this into a blog around a canvas that you can start to use, like the business model canvas. But yeah, it's been a pleasure sharing with you today, and I think we might have some time for Q&A, but also Twitter, LinkedIn, great for follow-ups with me. Happy to engage and discuss more with you.
Thank you, Alex. That was really interesting. Unfortunately, we're a bit behind schedule, so we don't have time for live questions. But yeah, I would encourage everybody in the audience to get in touch with Alex directly. His Twitter is mentioned on the bottom right corner. Also, please feel free to write your comments. We will make sure that they reach Alex and he will be able to answer you offline. Thanks a lot, Alex, once again. Appreciate it for you joining us, and yeah, hope that we'll see each other again.
Yeah, thank you very much.
Thank you. Bye-bye.
Accepting payments simply and securely is what we do. For 20 years, we've helped hundreds of thousands of businesses simplify payments with products designed for an evolving world. Our integrated payments technology is active in 120 global markets, and our payment methods are trusted by tens of millions of consumers. So whatever your model, size, or sector, plug into PaySafe to grow your business with confidence. If your business doesn't stay current, it can lead to frustration on all sides. And your customers have an ever-changing array of ways to pay: cash, card, via a digital wallet, or a bank transfer. We accept over 70 different payment methods, online, in-store, or on the go. And with our wide menu of tools, applications, and banking relationships, you can provide your customers a secure, instant, and personalized payment experience. Plugging into PaySafe means connecting your customers to the ways they want to pay.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained.
track of Ista 2021. Our next speaker is a software engineering team leader at Musawa Soft with more than 10 years of experience in the industry. His keen interests are actually in the area of development of large-scale enterprise systems. He has led teams that were executing projects for giants like the BMW and Volkswagen. Currently, was working on a PhD with the topic Internet of Things in the sphere of healthcare. So he's here to share some insights about it. Welcome, Ivo. Nice to have you here. And the stage is yours.
Hi, everybody. Thank you all. I will talk today about the development of and the usage of Internet of Things in healthcare. The development of computer technology in general, and especially wearable devices, Internet of Things devices, impacted all aspects of human activity lately, and the prices of such devices are very low, even to the end user. And the IoT is one, and the IoT is one of the most intensively developing technologies also in the area of healthcare. The technology has allowed the creation of a variety of devices for measuring and monitoring the vital signs of people that are in addition to the specialized medical equipment that's already existing. And there are many IoT devices for monitoring vital parameters that can be used both in hospital and in outpatient setting.
Excuse me, Ivo, for interrupting. It seems like your sharing is stopped at the moment.
Has it? Okay, I will try to share again.
Bug fixing on production.
Yeah, happens. Just a second. I can't find the sharing option.
The green button in the middle.
Yeah, true. Now you should be seeing the presentation, right?
Great, thank you.
Yeah. Okay, so those IoT devices can record the received information locally or use mobile communications to transmit it in real time to specialized platforms. There's really a huge variety of such IoT devices at the moment, and they're available on the market. I'm sure that most of you here have such, like smartwatches. I have one, for example, fitness bracelet, and there are also specialized solutions for monitoring certain parameters of the body and the environment during people's daily activities. The collection of large amounts of diverse information like this can improve the diagnostic activity in medicine, and also it can be used to monitor the process of post-hospital recovery. Currently, the devices can record not only your heart rate, like the devices we use in our everyday life, but there are more advanced devices that can record EKG, blood pressure, sugar saturation, and even more. I will start by showing you one such device, which is called the Exoskin. And the Exoskin is part of one rapidly developing area at the moment, which is smart garments. This is actually a shirt. Recently, we have purchased one Exoskin for a project at the university. And the Exoskin has also improved version, which is called Astroskin. Both are developed with collaboration with the Canadian Space Agency and give very accurate readings. The garment itself includes textile sensors that are embedded into a relatively comfortable shirt. I say relatively because it is pretty tight in order of the sensors to work correctly. And it gives a precise and continuous cardiac, respiratory, monitoring. The exoskin has one lead that provides electrocardiograph, and the astroskin provides a 3-lead cardiograph. Just as a comparison, the EKG devices that are used in the hospitals where you lie down, you strip, they use sensors, and the Holters, those are medical devices for continuous monitoring, use 5-lead. So we are not there yet, but we are moving towards this direction. What is interesting in the exoskin and the astroskin is that they have event detection. The software that is applied with the smart garment can detect QRS events, and it has a 3-axis accelerometer which can detect fall events. First, I will answer what is QRS event. This is a medical term that refers to abnormality in an EKG. Basically, what you see on the presentation is one wave of the EKG, and those QRS are just points in the EKG. Any abnormality there, they're values in which those 3 points have to be. Any abnormality in those can be caused by some kind of heart condition. And what is interesting is that such smart garments have the potential in future to replace medical grade device, like for example, the Holters. As I said before, Holters are medical devices that continuously gather cardiac data, only cardiac data, and can be used to diagnose heart conditions. And I don't know if any of you have worn a Holter, but I can tell you from a personal experience that it is not a pleasant one, since it is not so small, at least a little bit older ones, and also they have wires everywhere, and you have to wear it the whole day in order for the medical personnel to get the data and analyze it afterwards. While a smart garment is much more convenient and patient-friendly, plus it provides additional data that is breathing volume, breathing rate, and temperature. When you add to that the fall detection that can be achieved using the 3-axis accelerometer, it has the potential to become very useful. And even though it is not yet considered a medical device, because it lacks the accuracy of the Holter and has not undergo clinical trials, as far as I know, it can be still very useful, for example, in elderly homes for people with chronic conditions, like, for instance, chronic heart disease, because just imagine living somewhere remotely, and for example, you faint from low blood pressure. The exoskin can detect this fainting event and send automatic notification to a monitoring center or a medical personnel, which is very, very useful. I will show you the garment, and I will do something that most probably I will be the first one that will do on this conference. I'm going to undress myself a bit so that you can see it. So this is the garment. I hope you hear me still. As you can see, it looks just like a regular shirt. What is interesting, I don't know how well you see it, but on this area, the fabric is a bit thicker. And here, actually, you have the EKG sensors that are embedded into the fabric. And on this side, there is a little thin cable that goes into a pocket. And in this pocket, is the actual device. This is the device of the exoskin, which is currently working, and it is paired with my phone. It's a little bit difficult to show on this camera, but I hope you see it. The device has to be worn on a naked chest, and the leads have to be wet, either with water or this conductive liquid that's used in the hospitals. And once you start it, you can open the application that comes with the exoskin and see the data that it provides. I wanted to share it on my screen, but I have a problem with the tool that's sharing it. So I will have to show it on the camera. Let me just try one last time. I think I will be able to share. Just a second. Because the application is on my phone, and I'm currently waiting for it to connect, but yeah, it won't work. Okay, I will just try to show it on the screen. As you can see, this is the application. I don't know if you can see it well, but as you can see, my BPM, my beats per minute of the application are quite high at the moment for me, maybe because I'm speaking. There is also respiratory rate, and the third metric is the lungs volume. If you, for example, if I start breathing a little bit more often, you will be able to see that the number should increase a little bit. And also, if I switch, you can see the real-time feedback from the sensors. This is my EKG, and this is the breathing rate. Here, the interesting is that if I breathe deeply, the graphic spikes immediately. It has a very fast response time, and keep in mind that this is being transmitted now through Bluetooth to the phone. And also here you can get the accelerometer, which is pretty flat. But if I jump now or if I fall, it will produce the same spike as well. All this data is stored not only on the phone, but the device itself has internal storage that can store part of the data. And after the data has been uploaded, it is also stored on the servers of the exoskin, and it can be accessed, and you can create your own software for analysis of this data. And the only thing you have to do is just use OAuth in order to be able to authenticate to the server. So the next thing I want to talk about is the Freestyle Libre glucose monitor, which is another device. It is a more common device that has been around for years. It is a sensor that can be used to track blood sugar, and it is especially useful for people who have the diabetes conditions. These people have to monitor their blood sugar levels as a part of the treatment. And usually the test for the blood sugar requires for you to use a needle and get some blood, very little, but still puncture your finger and analyze the blood. The Freestyle Libre sensor eliminates the need to use the standard blood sugar test because it is inserted only once into the upper arm and can stay there up to 14 days, where you can do pretty much everything with it. And the best part is that it is absolutely pain-free. I cannot imagine how annoying it is to have to do the standard tests every day, and I'm sure that some of you have seen this because it's been a while. It's been around for a while. Here the more interesting part is the next thing. I saw this. The man on the left is the greatest marathon runner of all times. Recently, he did something that was considered impossible. He ran a marathon in under 2 hours. And I saw the same sensor. If you check his arm, I saw the same sensor on his arm. And I was curious why he was wearing, because it would be very difficult to run a marathon if you have diabetes at that speed. And then I saw the same sensor on the man on the right. The man on the right is called Christian Blumenfeld, who won the Olympic triathlon gold. So I checked about this and find out that there is a company that creates a software which can use the Freestyle Libre sensor readings in context of sports to support fueling, because every aerobic sport uses at some extent sugar to fuel the muscles. And I was surprised how many athletes use this. During the 2020 Tour de France, some of the teams used it to get their fueling right on their bike computers during the competition. So they're riding their bikes, they have small computers on the bike, and they see the blood sugar in real time. As a result, of course, the International Cycling Union banned the sensor in their competitions, but still the people continue to use it while training to improve recovery. And this is a very interesting trend, as it seems a medical device, IoT device, is currently being used to improve sports performance. And not only that, it seems that after I checked, Christian Blumenfeld, the guy at the right, uses quite a lot of such sensors that supply medical data to optimize his training outside of the usual bike tech. He uses devices that, for example, measure blood flow in the legs, temperature sensors, and also portable devices that can measure muscle lactate. And also, I found out that in the sports area, and not only there the so-called recovery advisors. The recovery advisors are especially popular in the sports field, but they're used also in everyday life. Most of those contain only heart rate sensors. For example, I have such a bracelet that has a heart rate sensor, but it uses the data in a slightly different way. Instead of measuring the heart rate itself, they measure the heart rate variability, or HRV. And here we'll get a little bit medical. HRV is the variance in the time between the heartbeats. So if your heart rate is, let's say, a 16 beats per minute, it will not beat exactly every second, but instead there will be some milliseconds difference. And although heart rate variability manifests as a function of your heart, it actually originates from your nervous system. Your autonomic nervous system, which controls the involuntary aspect of your physiology, has two branches, the parasympathetic and the sympathetic. The parasympathetic side is characterized as the rest and digest system that allows the body to power down and recover. And the sympathetic branch activates stress hormones production and decreases the heart contraction rate and force the cardiac output and decreases the HRV, which is needed, of course, during, for example, exercises or mentally or physical stressful situation. Conversely, the parasympathetic system slows down the heart rate and increases HRV to restore the balance. The natural interplay between those two systems allows the heart to quickly respond to different situations. And when you have a high heart rate variability, it means that the both nervous systems are in balance, and that your body is responsive, and it is a sign that your body is very capable of adapting to its environment and performing at its best. This does not only mean sports performance, but I also mean handling everyday stress. This is very useful to handle everyday stress. The small compact IoT devices that measure heart rate variability, like the one I have, this is the so-called Whoop bracelet. Here's the link in case somebody wonders. It's just a heart rate sensor, but there the more interesting thing is the software, because the software creates a statistic, a baseline about your HRV, and provides insight when you are recovered and when you are stressed. And by having this information, you can adapt to the changes around you. For example, if you're stressed, you can slow down. And also, if you are exerting your body, you can see it very clearly. Since I'm using this bracelet, I have it since I think 8 or 9 months, and I wear it every day. The only 2 times that my heart rate variability fell really low, the next day I was sick. I mean, I had a cold. So this gives really good insight. And another topic regarding the IoT device is the telemedicine, which is especially useful during the COVID pandemic. The telemedicine is the remote diagnosis and treatment of patients by means of telecommunication technology. The COVID pandemic puts a big strain on the hospitals, and this becomes very important. There are at the moment devices like the one on the right that allow remote monitoring of patients, like for example, this one. This is actually a Holter, but besides being a Holter, with the 5-lead EKG sensor, it can also measure blood saturation, and it connects directly to the internet. It has a SIM card in it. And during the COVID pandemics, such devices are being used at the moment to monitor remotely patients. By having this device strapped on yourself, it can transmit data directly to a medical personnel, and for example, it can be seen when you get worse. And as a conclusion, there are really a lot of devices there that can be used in a hospital or also in recovery to improve both those areas. And although some of them are not that accurate yet, in the future, I expect that those will be very widely used in hospitals. And even currently, I'm working with a medical doctor from the anesthesiology department in the hospital to see how we can use those. And that's all from my side. Thank you. And if you have any questions, now is the time. If we have time, I don't know.
Yeah, we Actually, we're a bit behind schedule, so we don't have time for live questions, but I'll ask the audience. Feel free to ask your questions in the comment section, and Ivo would be happy to answer them offline. Thanks a lot, Ivo.
You're
It was
welcome.
really interesting to hear about the healthcare topic in the context of IoT. Thanks again for joining us, and yeah, have a nice day. Bye-bye.
Thank you. Bye.
Радо, не знам дали ме чува някой от вас.
Чуваме те, да, здрасти.
Добре ли е звука? Всичко здравейте, момчета.
The Hershey Company is an organization that's driven to bring positive impact to the world. We have in excess of 80 iconic brands such as Reese, Kit Kat, Hershey's. Hershey's looking at how do we evaluate and manage the brands that we are delivering to ensure that they're profitable. So technology will help to bring a lot of that together, whether it's through how we actually process certain types of transactions, whether it's how we evaluate and manage the financial performance of certain brands or certain customers. The organization was faced with making a decision and moving directly to adopt SAP S/4HANA Central Finance. We see it already leading to quicker decision making. We can do a lot of analysis on a brand, on a customer, on a specific cost center, as well as on vendor activity or customer activity. SAP was key to Hershey's overall success.
Welcome back to the Ista Dev Track. Just to briefly introduce our next speaker, his name is Atanas Kuzmanov. He's a senior software engineer who successfully led a large-scale project involving cross-domain collaboration. His capabilities and passion for technology constantly led him to an interesting road of discoveries and adventure. He's here with us today to share some of those. Welcome, Atanas. Nice to have you.
Thank you very much. Nice to be here. Hi, everyone.
You can start.
Okay, cool. Right. So, hi, everyone, and welcome to my talk about API testing and validation, contracts, and API-first development. So, first, a bit of background about myself. My name is Atanas. I'm a software engineer at Schwartz IT, and I work for the IT Solutions Development Department, and I'm part of a team which develops and maintains our CMS for property management, among many other systems. And why am I talking about this topic today? So basically, I was given a task which I finished quicker than expected, and I was crying out for work. And my colleagues gave me a task as a bit of a challenge and maybe as a bit of a joke, as it was me being unaware that it was something that they had attempted to do several years ago and that they failed to do it. And there was a good reason for it. The technology wasn't quite there at the time. And after a lot of hard work, I was actually able to solve it. And why am I giving you this talk today? Well, at the time, to the best of my knowledge, it was only us at Schwartz and a few other companies that had used this technology in this way. And I've seen more adoption in the past 3 months by other companies. I've seen some GitHub repos pop up, but very few or none of them are really talking about it. There are almost no blog posts, no tutorials, etc., etc. So I want to share my findings as I think they're immediately applicable, practical, and beneficial. So just a very quick look at the agenda. We'll cover some basics as I want to make this talk accessible at all levels from juniors to seniors, and we'll see what, in basic terms, what is an API. We'll then see how that applies design first versus code first in terms of API development, and we'll see what is this thing, an API contract, and why API first is so important. And in the end, we'll tie this whole thing neatly into a knot with a demo. So let's get started. If you came here, first of all, for the IPAs, you're in the right place, but the wrong time. So APIs now and IPAs later. Just a little bit of an icebreaker joke. And before we start, I'd like to make another small disclosure. I'll be using the following presenting technique I learned from the Head First books and an ex-colleague of mine to keep your brains focused. So the presentation has more text than usual, and that's intentional because me personally as a viewer, when I'm rewatching presentations, I like to pause and actually read the text to really get into the contents of it. So it's not a bug, it's a feature. And I'll randomly show you pictures of wolf facts and photos throughout the presentation. This is a brain focus technique to give your brains a bit of a breather and then to bring your focus right back into the presentation. So the wolf is a noble creature and it's driven to extinction in many parts of the world. And I personally have done a small donation to the Euronatur German charity as one of its doings is protecting wolves in Europe. When I donate to charities, I don't tend to stick to any just particular one, but in this case, since I'm using wolves in the presentation, I chose that one. So let's get started. First of all, what is an API? An API stands for an application programming interface. And it's a connection between two computers or between two computer programs. It's a type of software interface which offers service to other pieces of software. A document or a standard that describes how to build such a connection or an interface is called an API specification, and a computer or software that meets this standard is set to implement or expose an API. So each time that you access an app on your phone, like Facebook, or check the weather, you're basically using an API. So to explain this better, you can research on your own leisure how an API can be explained with a restaurant example. Basically, the waiters or the messengers will be your APIs, which take your request as a client to the server, which is the kitchen, which will prepare your food. And then the waiters will deliver it back to your table, which is the response, in this case, your food. So now imagine that you're in a team that's building Twitter, and you have a front end and the back end, and they need to talk to each other so that the front end can display the tweets that are stored in the database in the back end, for example. Now you need to build the front end and the back end in parallel, and the connection over them happens over an API. And in the previous slide, we mentioned that a document which describes how to build such a connection is called an API specification or an API contract. You're given such a document and you set off to build the two front end and the back end in parallel. Now, if the two teams adhere to the contract, everything will be good. And when they go live, their APIs will be able to talk to each other. But if intentionally or by mistakes, you break the contract or the API specification, when you go live, some of your APIs will be able to talk to each other while others not, which will result into production bugs. And this is where Open API and contract validation comes in. It's a way that we can enforce and test APIs and API contracts. So in the current situation of increased remote working, having a common simple medium of communications, such as an Open API document, is indispensable in meeting your requirements when building APIs. Things get even more exciting when such a document can serve as a contract, generate clients, servers, and documentation in a plethora of languages, put your developers and clients first, have automatic fail-fast API validation, is cross-platform and language agnostic, can be both machine and human readable in YAML or JSON formats, speeds up development, prototyping, and reduces costs. And to me, all those things sound exciting. Now, when building software, there are several approaches you can take, and let's discuss it as high-level design first versus code first development. So with the code first approach, you start with your IDE, typing out some code, and somewhere at the back of your mind, you're thinking that eventually an interface will have to be created to deliver that service. However, the core functionality is, you're focused on the core functionality and not the interface, and that's what's driving the development rather than the other way around. And when the time comes to implement the interface or the API to deliver your service, the core service is mostly done, so it's driving your implementation. And to the user who ultimately used the interface or the API, it might feel like it wasn't developed that well, like an afterthought, like it was tacked on. This is a synchronous flow encountered more traditionally in the traditional waterfall model, and delays at any point will push back the delivery line and it will be more expensive. Now, in comparison with an API first approach, instead of starting with the code, you start with designing, planning, testing, mocking your API. The process is aligned with agile software development, and it allows the team and any stakeholders, technical and non-technical QAs, to weigh in on the process early and often, before a lot of time and effort has been sunk into the project and before a lot of cost has been sunk into the project. So once the direction has been solidified, then the contract can serve as a contract that all the teams can begin working towards in parallel. So let's drill down a little bit deeper. Let's talk about API development in terms of design first versus code first. Like any product, the concept of an API starts with identifying an opportunity and a plan to capitalize on that opportunity. From there are two approaches that you can take to develop the API. The design first approach, where you design the API contract first before writing any code. Then the plan is converted to human and machine readable contracts, such as Open API document in YAML or JSON. And then from that document, you build the code. And then there's the code first approach based on the business plan. You start directly coding the API, and a human or machine readable documentation can be generated later on, like Swagger documentation or something like that. Now, random wolf fact. So true love, once a wolf has found a mate, they tend to stay together for better or worse, through sickness and health, often until death do them part. They have been known to sacrifice themselves for the survival of other wolves. So move over Romeo and Juliet, there's a new couple in town. So there's the advantages and disadvantages with both approaches. And in the end, choosing the right approach boils down to your immediate technological and strategic needs. So first, let's look at some negatives of the code first approach. Code first doesn't mean leaving out the design. Rather, it means the design is hidden away in Jira tickets, Confluence pages, documents, napkins even, and potentially lost to history forever. This can lead to some potential problems. You can have frustrated users. The wrong API can be built if you're not adhering to the specification, and missed opportunities. If the documentation isn't available, other teams might not discover your API and build the same thing over again, resulting in duplicated effort. Now, let's look at some of the benefits and good use cases for code first approach. So when delivery speed matters, if delivery speed is one of your important success factors, then coding straight away is obviously the better approach. And if you're developing a small internal API, then again, something that's going to be used only by your team or by your organization, then code first is the ideal approach for you. Now, just pardon me for a sip of water. Right. Now let's look at some negatives of the design first approach as well. It's hard work. To be honest, it takes a lot of time and deliberation for any team to move to design first. And also it takes commitment. Companies must be intentional no matter their size. The shift to design first doesn't happen on its own. Now let's concentrate on the benefits of the design first approach, which far outweigh any challenges. You get product-driven APIs where team can include managers, QAs, and other technical people early and often on the project. Teams can work in parallel. You get shorter feedback loops, and you can view your contract as a source of truth. And if you're delivering mission-critical APIs, if your clients are developers, developer experience will matter. Random wolf fact. It's all in the howl. So wolves do howl at night. And these soulful calls have nothing to do with the moon, like most people think. Their penetrating, hauntingly beautiful howl is a primary communication tool, both between lone wolves and their pack, as well as between packs. So we can already see that design first or API first is the better approach. But why? In a world where speed to markets hold premium, why would you spend valuable building time to focus on the API first? Is it worth it? There are several benefits for choosing the approach that far outweigh delaying your time to market. So you'll get earlier validation, you'll get a clear abstraction layer, you'll decouple dependencies, and you ensure quality, predictability, and stability to extend especially other developers. A couple of real-world examples. So Twilio is an API-first cloud platform which is tailor-made to support their clients. Their APIs is their products. And speaking from personal experience at the BBC, building a new breaking news app in time for elections with a cross team of 4 teams in 3 different locations, our main channel of communication was an API contract, and without it, we wouldn't have made it in time. And again, speaking from personal experience at Schwartz IT, we use spec-first API development and have seen some great benefits, including reduced development times, tighter feedback loops, and a better API design overall. All of our backend services currently have accompanying spec projects. Currently, most of them are interfaces, but we're slowly moving them to open API specs, and we intend to use it for any new projects from the start. Now, your API is your contract. And what is this API contract thing? So it's a shared articulation of what an API does, both in machine and human readable. It's basically what your service is, what you're offering. It uses tools such as OpenAPI to describe the requests and responses of your API and functionality offer all over your endpoints that people can use. It's something that both providers and consumers agree upon, and then they build, develop, integrate, normally for an agreed upon price. And an API contract helps mitigate change, or at least communicates it. So if you provide an open API spec ahead of each new version release, it will give your developers or your clients a needed time and certainty so that they can review it and agree if they want to commit to it or if they want to change something. So this sounds great and all, but there is normally no way to enforce a contract. So people might keep it, but then they might not keep it. And this can have some monstrous consequences. If only there was a way and relevant tools to achieve this, and there is. So enter contracts first, development, and contract testing and validation. So what is this contract first thing? Contract first development is about making your intent clear across all the team members and external teams. By using a tool like OpenAPI, you can define your programming API clearly at the very beginning. And you also update the contract before you make any change so that everyone can review it and agree to it. So what is this contract testing thing then? So this is the way that we enforce and validate our contracts and our API specifications. When compared to end-to-end testing, for example, the approaches in contract testing enables you to create consistent curves in your pipeline, speed and complexity effort that look more like the curves in the diagram below, and you still maintain many of the safety guarantees of end-to-end tests as well. So how do I convince you? Well, the main thing that any organization cares about when it comes to software development, it's normally cost. And when building a product, your time is probably the biggest cost to an organization. So there will be an initial overhead when you need to move to API first and you need to integrate it in your pipeline. But using contract tests in conjunction with or as a replacement for traditional end-to-end tests will be cheaper in the long run. And that happens by several reasons. Basically, contract tests help provide very fast feedback loops. They clearly identify where the problem is when something fails, and they ensure that only the parts of the API that will get built, that will get used, get built. Also, they can save compute time and resources. Tooling. So let's see how do we achieve all of that. We're going to need the right tools for the job. And the first tool that we need is an OpenAPI spec. So it defines a standard description format and a language agnostic interface to REST APIs. This shows both humans and computers how to discover and understand the capabilities of your service. Basically, what are you offering? What are your endpoints? What are the parameters? What authentication methods do you have? Contract information, license, terms of use, and can be written both in YAML or JSON. Here is an example of the anatomy of an OpenAPI spec. Now, I'm using an example of an online pet store, a very basic CRUD application, and I've highlighted a few pieces of interest. So there you can see some path getting defined, some methods, some parameters, some responses. And the next really cool bit is the schema. So the schema actually allows you to model an object. So let's say that you have an object for a pet, and a pet will have an ID, which could be of type integer, and it can have a name, which is of type string. So you can model that and then reference it in your API spec. This helps you to abide by the dry rule. So do not repeat yourself. You don't have to rewrite the same object over and over again. You just reference it from the schema. So I think that's pretty cool. Now, the next tool that you need is Swagger. Swagger is a set of open source tools built around an OpenAPI specification. And once you have an OpenAPI spec document, you can combine it with Swagger and you can use it to generate a stub. And then the only thing you'll need is to basically write some glue code or some, some logic code, and your API will be ready to go. You can generate clients in over like 40 languages. You get interactive documentation that you can try it out in the browser, like on the screenshot right there. And you can use the spec for testing, automated tests even, and documentation as well. So what about documentation? So do any of these sound familiar? Code first, documents later, or we'll write the docs when we have time. Almost definitely for sure, maybe. So I'm personally guilty of both of these and I've done it in the past. The next tool that you need is an OpenAPI generator. So this tool is something that you can give it an OpenAPI spec document, and you can use it to generate for you API clients, server stubs, documentation, configuration, etc., etc. This is basically what Swagger, the tools of Swagger use underneath when they generate something for you. Now, there are several different generators floating around. I think Swagger have one of their own, which is now currently owned by SmartBear. I think OpenAPI have one of their own. I think there are a couple of others floating around. But in the demo, I've used the one from OpenAPI themselves. So that's a pretty solid generator. Now, here is a really important bit of kit. So after spending quite a bit of time researching how I can do request and response validation for our existing APIs, without having to rewrite all the tests, write a whole new suite of tests, or write a small project or like a small library to do all the work for me, I found the answer. And Atlassian have done it. So Atlassian have built a request validator Java library for validating HTTP requests and responses against an OpenAPI spec document. It has several modules and different frameworks, and I'm using one of them in the demo. I'm using the Swagger request validator with the rest assured module. So basically it allows integration with the rest assured testing library. Now, when I was using it, and to the best of my knowledge, the OpenAPI REST Atlassian request validator was free. I think it's under the Apache license, but you can check out their repo and make sure. Just pardon me for another sip of water. Pardon me. Next, we need some tools for validating the front end. And here's a couple of OpenAPI validators for Express.js. They automatically validate API requests and responses based on an OpenAPI spec. Oops, sorry. So these libraries integrate with an existing API application. You simply install the validator on your app, you point it to an OpenAPI spec file, and define and implements the routes any way you want. So this will validate both, it can validate requests both coming into your frontend as well as requests going out of your frontend, for example, to the backend. So again, pretty powerful stuff. Now, all the usual suspects, I'm using all of the following just for the demo. So we've got Java, Spring Boot, JavaScript, TypeScript, Angular, MongoDB, Docker, etc., etc. Random wolf fact. So the wolf represents strength, loyalty, family ties, caring, expresses freedom and fortitude. And the Japanese word for wolf, okami, means great god. So I think a pretty cool animal overall. Demo. Now, due to the format of this conference, we will not have time for me to do the live coding demo, but I've recorded it for you on YouTube, and you can access it through these links or to these barcodes. You can scan them right now. It's in 2 parts, so it conforms to the YouTube standards about time limits. And I've also added chapters to it, so you can scroll through it or just see the things that are interesting to you. And I'll just give you brief descriptions while you're copying the links or something. So in the demo, basically what I do is I get an OpenAPI spec file, and I use it to generate the backend in Java and Spring Boot. Then I use it to generate the frontend with Angular and JavaScript. Then I use Atlassian's validator to attest to the backend, which validates the API. Then I use Express OpenAPI validate to attest to the frontend and validate the frontend API. And then I demonstrate how these tests fail if you breach the contract. So either if you make changes to the spec and then you don't make changes to the code, or if you make changes to the code intentionally or by mistake, the test should still fail and tell you, oh, no, you need to change something or you need to talk to someone. So I hope that you enjoy the demo and that you see it and that you find it useful. I'd like to leave you with some closing thoughts. I'd like to leave you with the lyrics from the song Everything Counts by Depeche Mode. The handshake seals the contract. From the contract, there is no turning back. The holiday was fun packed. The contract still intact. So keep your contracts intact, people. Now, a few slides of references. These are all the things that I use for the demo and for the presentation. You can check them out when the presentation is available. And I'll be available for questions. But first, let me just start with an icebreaker question. Well, I've been asked before if you can use OpenAPI for GraphQL. And the short answer is no. So GraphQL breaks REST standards. And unfortunately, as of 2021, there is no standard way to show GraphQL endpoint or link a GraphQL UI to a Swagger UI. GraphQL APIs are usually documented through their own facilities, such as GraphQL Playground or something like that. But because GraphQL and REST are competing with each other, so GraphQL vendors, they want developers not to use REST, but rather use GraphQL or one or the other. I'm hoping that in the future, the advantages in this much of both will be better understood, and there will be more balanced view of when to use one or the other, depending on your use cases. But just in case, here are a couple of translators that you can use to translate an OpenAPI spec to a GraphQL document or spec. I haven't tried these. I haven't had to try them yet. So you can check them out, or maybe you can even find better ones. So now I'm pretty much yours for questions, if there are any.
Thank you, Atanas. A quick question from my side. Do you think OpenAPI can be used for real-time validation? What's your view on that?
You can. So I've tried it out with the Atlassian library as well. For example, I think I tried it with the REST template module. You can use it. It's a bit trickier to, I think, to set up. You have actually levels of configuration where you can fine tune it. But if you're using it for an existing project, it might be a bit harder because you might get a lot of false positive, or it might even try to validate something like requests for downloading like CSS files or other things. And it might need a bit more hard tuning. If you're starting from scratch, I think it might be easier to use it just both real time and just for tests.
Okay, so far we don't have any question from the comment section. So one more from my side as we have the time.
Sure. Yeah.
What about alternatives? Can you think of any?
So yeah, there are. I certainly heard a few things going around. I personally haven't tried them, but there is, I think, a tool called Pact, I think is one of them. And I've also heard about something called Stoplight, I think. Again, I haven't had time to research and try them out, but I think there will be probably even more popping up, as I think this way of working is gaining popularity. So like OpenAPI and Swagger aren't really innovative, but using them to validate contracts and API contracts and API specification, I think that's the innovative bit of my presentation. That's kind of the thing that I wanted to demonstrate.
Okay, so many thanks from our side for your talk. It was really interesting to hear. And wish you a nice day. We'll be happy to have you back next year.
Thank you as well. I hope that people find it useful and start using it. Thank you again for having me. Pleasure.
Thank you. Bye-bye.
Bye-bye.
Smart IT е технологичното ядро за разработка и поддръжка на собствени комплексни бизнес решения на Management Financial Group. Български финансов холдинг в сферата на небанковите финансови услуги, опериращ в цяла Европа. Решенията, които Smart IT създава, подпомагат дигиталната трансформация на бизнеса. Днес звеното разполага с 130 специалисти, заети в разработката на ERP-системи, бизнес интелидженс, финтех платформи и още. Дейността на компаниите се разделя в 5 дивизионни направления. Дивизия Home Collected Credits има най-голям дял от групата с общ оборот от близо 140 милиона евро за последната година, с представителства в Централна и Източна Европа.
Казвам се Радостин Богдан. В екипа на Smart IT съм от 6 години. Нашите партньори имат нужда от решения, които позволяват лесно, бързо и гъвкаво да стартират и развиват бизнесите си. Гордеем се с най-мащабният ни проект – адаптивната финтех платформа SmartCheck, която им носи това конкурентно предимство.
Hello, and welcome back to the Dev Track on Ista 2021. Our next speaker is, his name is Anton Sankov, and he's software engineer at VMware Carbon Black, where he's helping to define the future of container and cloud technology. His background is strongly focused on engineering. He previously worked at market leaders in multiple industries, payment, cloud, infrastructure provisioning as well. The Kubernetes ecosystem is something that is very interesting for him because of its elegant solutions in real-time, in solving real-time problems. So he's here to share his vision about the next phases of Kubernetes. Welcome, Anton. Nice to have you here. The stage is yours.
Thank you, Christo, for the introduction, and thank you to the organizers for having me here today. Hello everyone, as you've heard, my name is Anton. I am a software engineer at VMware Carbon Black, where I am working on a product about container and Kubernetes security. As you probably already heard and saw, today we're going to talk about Kubernetes. But what is actually Kubernetes? Kubernetes is an open source container orchestration tool. It was developed in Google, open source in 2014, and for the past 7 years became the de facto standard for managing and deploying container applications. However, today we are not going to talk about deployments or container orchestration. We're going to talk about how we can take Kubernetes to the next level, and that is using it as our application development platform or framework, if you'd like to call it that way. In order to showcase this approach, we're going to build something. And what we're going to build is a conference management system. Think, for example, of Ista conference. On Ista's website, you can go and you can see all the sessions with more info about each conference talk, more info about each speaker, and so on. So we're going to build something similar, only ours is going to be a bit simpler. Our domain is going to consist of two main models, a conference talk and a speaker, where each conference talk has a title, a summary, and a speaker, and each speaker has a name and a bio. In order to build this, we need, in technical terms, 2 or 3 main building blocks. And that is, first, an API backend for creating, reading, updating, and deleting resources, or the so-called CRUD API. Then we need a database to store these resources in. And last but not least, we need a UI to visualize everything. Now, Kubernetes cannot really help us much with the UI, so we're not going to talk about this today in today's presentation. We're going to focus more on the other 2 parts of our system, the API backend and the database. And now some of you might say that this is a pretty standard problem to solve, and there is more or less a standard way to solve it. And you will be right. The standard way would be to pick your favorite programming language, bundle it with the web framework, choose some database engine, maybe a UI framework, and use this as a scaffold for your application. But this approach is not without its pros and cons. Let's see what they are. First of all, basing your entire application on a framework like Spring or Django has both positive and negative sides. On the positive sides, these frameworks are quite big. They give you all the stuff out of the box. They have been around for a long time and they are used by many people in production. They have long-term commercial support, basically everything you might need or want from a framework. On the negative sides, however, the fact that these frameworks contain a lot of stuff out of the box means that they're quite big. And probably you won't be using everything that these frameworks have to give you. So you need to either spend the time to strip them out of all these unnecessary parts, or you need to ship your application along with them, thus making it bigger and slower. Also, such tools gives you the capabilities to write an API, but they don't actually guide you through the day-to-day operations of managing an API. For example, if our API is going to be public, if we're going to give it to our customers to interact with it, we're going to need documentation. And indeed, documenting an API nowadays is not a hard thing to do. You have standards like OpenAPI. You have a lot of tutorials online on how to document an API. So this is not the challenge here. The challenge comes when you have to make sure that this documentation is always up to date with the API. What I have often seen in practice is developers updating the API, but forgetting to update the documentation. And what happens in this case is that your customers, they start seeing things in the UI which they don't know anything about because they are not in the documentation. And they get confused. Or your API having capabilities which your customers are not using, again, because they're not documented and your customers don't know about them. So you need to figure out a way to tackle this problem by yourself. Another thing is API versioning. Your product will evolve and the API will evolve as well. And inevitably, sooner or later, you need to make a backwards incompatible change to your API. Backwards incompatible change means deleting a field or renaming a field or changing the type of a field. Basically something which will break existing integrations. And the question here is, what do you do in this scenario? Do you release a second version of your API with the new changes and maintain both the first and the second version simultaneously? Do you deprecate the first version? Do you just delete the first version and tell your customers to update immediately? These are all questions which you have to answer by yourself, and on which these tools are not opinionated on. So you're on your own here. Enough with the problems. Let's see what is the alternative that we are suggesting. As I began, we're going to use Kubernetes as our application development framework. What this means is that we're going to build an API backend entirely as an extension of Kubernetes API. We are not going to build an application which we will deploy into Kubernetes, but we're going to extend Kubernetes itself in a way that Kubernetes is our API backend. We can do this because Kubernetes is by design flexible and extensible, and it provides you with a lot of constructs which allow you to extend Kubernetes in a way that it fits your use case. I'm talking about things like custom resource definitions, admission controllers, and operators. And indeed, people have been using these constructs to extend Kubernetes for a while now, and this is what we're going to do in today's talk. Let's start with our domain objects. We're going to represent them as custom resource definitions, or CRDs. Now, if you don't know what a custom resource definition is, it is exactly what it sounds like, your own custom Kubernetes resource. The same way that you have resources like pods, deployments, services which come from Kubernetes, the same way you can define your own custom resource, which you have full control over it. You define what properties it has, what types are these properties, what happens when you create one, what happens when you delete one. And we're going to leverage these capabilities for our domain objects, the conference talks and the speakers. Now, in more technical terms, what happens when you create a new CRD is Kubernetes registers new API endpoints to the Kubernetes API so that you can use them to interact with your resources. And Kubernetes also provides implementation for these endpoints. This implementation includes serialization and deserialization of the request and the response, validation based on the open API spec of the resource, and the logic which reads and writes from the database. Let's see how this looks in practice. This is the custom resource definition for our conference talk object. This is a Kubernetes spec file. We see its kind is custom resource definition. And down below, we have all the fields for our type. The name of our kind is conference talk. The API group is istacon.org because we are at Ista. And we see we have one supported version for this API. This is version v1. And we see it has an open API spec, which consists of the three fields we talked about in the beginning: title, summary, and speaker ID. Now, this, as you see it, solves two of the problems we talked about in the beginning, the documentation and the versioning. Why does it solve the documentation problem? Well, because CRDs are usually something which is public. So you can just give this CRD to your customers and you can say, this is my API, this is how you interact with my API. And because, as I said, custom resource definitions are something quite standard in Kubernetes, people who are already familiar with Kubernetes and with custom resource definition can easily get familiar with your custom resource definitions as well. Now, if your customers are not familiar with custom resource definitions and you don't want to bother them with Kubernetes specific things, this here is just an open API schema. So you can use this as your source of truth and generate another documentation, which is Kubernetes agnostic, based on the fields in your CRD. But the bottom line is that this represents your API, and this is how your API looks like. And because Kubernetes will provide the implementation of this API for you, there's no way that your documentation will diverge from your implementation, because one begins with the other. If you listen to the previous talk about API first design, this is basically one way to do API first. About the versioning, if we want to have second version of this API, the only thing we need to do is we need to add another entry in this version spec here. For example, v2, which will have different API schema, which will not be compatible with version 1. And for things like deprecations or removals, the only thing we need to do is we need to tweak these fields, these two fields here. And this way we can deprecate or remove an API. And again, this is all pretty standard in the Kubernetes world. This is our second CRD for our speakers. I don't have much to say about it because it's more or less the same. We see now the kind name is different, is a speaker. The API group is the same, istacon.org. And again, we have one version which has an open API spec, and we see the two fields for the speaker in this open API spec. This is the API scaffold. This is how the API looks like. But if you want to create actual instances of these objects, we can do it like this. This is again a Kubernetes spec file which represents our custom resource. We see now the kind is conference talk and the API version is istacon.org v1, basically what we saw in the previous slide. Then we have some metadata, and then we have the spec with the three fields for these resources. And we have the same thing for the speaker. Kind speaker, API version istacon.org v1, some metadata, and the spec with the speaker fields. Applying these two YAML files to a Cube API, which already has the CRDs from the previous white register, will automatically create these two objects in the Kubernetes database for you, and you can later get them, read them, interact with them in whatever way you like. I have recorded a short demo to see how this looks like in practice. So I have a Kubernetes cluster here, and I'm interacting with it with kubectl. And what I'm doing here is I'm applying the YAML from the first flight. I'm creating the custom resource definition for the conference talk. And I see that I have it now created. The second thing that I will do is I will create an actual instance of this custom resource definition. So I'm creating a conference talk custom resource. And now if I kubectl get my conference talks, I will see that I have one object of this kind, the Kubernetes extensibility, which I created 7 seconds ago. If I want to see more details about this object, I can just specify its name when I'm kubectl getting it, and this will show me the full spec of this resource. Here it is, and we see we have some metadata which is added by Kubernetes, and in the bottom we see the spec which we have specified. So this is how our API looks like. And this is kubectl, but we can interact with Kubernetes in other ways. And one way is to just do an HTTP call to the Kubernetes API. So I can just make a curl request, and this is how the HTTP API looks like. Istacon.org, which is our API group. Then we have v1, which is the version, and then the name of the resource, which is conference talk. And if I execute this GET request, I will see basically the same thing we saw previously, only in a slightly different format. It's now in JSON format, and we see here in the items we have an array of conference talks, and we see we have one conference talk, which is what we saw previously, the same one, and it's back here. Okay, so what have we achieved? What have we achieved so far? We have a CRUD API backend, which is entirely as an extension of Kubernetes API. And we have the ability to create, read, update, and delete resources via the Kubernetes API. And these resources are automatically stored at the Kubernetes database. And we achieved all of this without writing a single line of code. It looks something like this. We have a user which creates conference talks. Then we have the Kube API server, which writes these to etcd. And the other way around, a user which reads conference talks, we have the Kube API server which reads them from his database and returns them to the user. Okay, but what if we have more business logic? What if we have some dependencies between our objects? For example, when we are creating a conference talk, we need to make sure that the speaker referenced in this conference talk actually exists. Or we want to run some actions when a conference talk is created, like send an email or publish a social media post. To achieve this, we cannot do it with CRDs alone. We will need to use more of these extensibility constructs we talked about. So let's see what they are. Starting with validation, we can use admission controllers for that. And this is a controller which allows or denies the creation of a resource. What it does is it reviews the request before that resource is created. Based on some logic, allows or denies the creation of the resource, and the Kube API server respects this decision. Kubernetes gives you many admission controllers out of the box, mostly used for security and authorization, but it also gives us the capabilities to write our own admission controllers. And in our case, this is the perfect place for implementing our validation. In more technical terms, an admission controller is just a webhook which is called by Kubernetes. This webhook contains some logic. It receives a standard request, and it should return a standard response, which response contains whether the request should be allowed or not. Then the Kube API server will parse that response, and it will do whatever the response tells it to. The picture now looks something like this. When a user creates a conference talk, it first goes to the admission controller, which allows or denies the creation. If it denies it, the given conference talk will not be created, and the user will get an error. If it allows it, the same thing will happen as before. The Cube API server will write this resource to the database, and you can later read it, update it, delete it, whatever we want to do with it. Now we know how to do the validation, but what about some post-create actions? For this, we can use operators. An operator in Kubernetes is something like a controller for custom resources. What an operator do is they listen for create, update, or delete action of a given custom resource. And once that happens, they run some code. In our case, this would be the perfect place for implementing the business logic. In more technical terms, an operator is a web service which interacts with the Kubernetes API and listens for resource changes. And when that happens, it runs some code. The good thing about operators is that we can generate most of the logic based on the CRDs. So all the Kubernetes specific logic about interaction with the Kube API, listeners, reconciliation loops, all of this, we can get it generated by us. And the only thing we need to implement is our business logic, which is basically one method which says when a resource is created or updated, execute this logic. And now we know how to achieve this as well. The picture now looks something like this. We have a user which creates a conference talks. This is verified by an admission controller. If it's allowed, it goes to the Kube API, which writes it to the database. And simultaneously, the operator will hear that the conference talk has been created, and it will run all the logic which we have implemented it to run. Now, I would like to mention some details. First of all, this solution uses etcd as a database. etcd is a NoSQL database which comes by default with most Kubernetes installations. Kubernetes uses it to store the desired state of the cluster. And in our case, we are reusing that to store our resources as well. In our scenario, this is okay because our data is really tiny. It's like 2 or 3 fields. But for more complex use cases, for if your data is going to be, if you're going to be using big data or you have really complex objects, you'll be better off using a regular database like Postgres or MySQL, because etcd isn't really built for high scale and for big data. And in this scenario, you will be better off using another type of database. Even if you do need to use that, you can easily provision a database in your cluster with a database operator. You already know what an operator is, and most of the database vendors, they provide you with operators which you can install in your cluster, and then using some CRDs, provision databases for you in your Kubernetes cluster in a Kubernetes native way. Another thing which I kind of mentioned, but I wanted to reiterate here because I think it's important, is that kubectl and YAML files is not the only way to interact with your Kubernetes cluster. This is more or less the standard way and what we are used to. But how this works under the hood is that Kubernetes actually exposes an HTTP REST API, and kubectl is just a wrapper on top of that. So if you need to do some integration, or you just don't want to use kubectl and YAML files, you can easily just use the REST API and interact with that. And of course, you already saw in the recording how, with a simple curl request, we got our conference talks from the API server. I would like to show you more, but unfortunately, I don't have the time today. So if you want to see the full picture with the code, the implementation of operators and admission controllers, it's all in my GitHub profile. It's asankov-cb/Kubernetes-extensibility. There you will find instructions on how to run everything in your Kubernetes cluster, how to play around with it, how to modify it if you want to, and you can check it out. If you have any questions or feedback, you can contact me. I'll be happy to answer. My socials are on the next slide, or you can just open an issue here on GitHub. Now, this is the end of the presentation, and if there's something to take away from this is that there are many ways to build a web application nowadays, and new technologies like Kubernetes motivates people to start building applications in new ways. Of course, this approach is not without its negative sides. So it's all a matter of trade-offs, and when you are evaluating how to write your next application, you need to make the right choices and see what works best for you and which trade-offs you're willing to make. And currently, we see this approach really popular for product which need to provision something in Kubernetes, like databases or some lifecycle management of some components. Yeah, thank you very much for the attention. I'll be happy to take any questions now or later on any of the links here. Thank you.
Thank you, Anton. Those were some very interesting insights that you shared. So far, we don't have any questions from the audience, but I have something in mind that I wanted to ask you. Can you think of any practical examples of using this approach? Any projects that are implementing it?
Yes. Yeah, so as I said, it's really popular in lifecycle management. And one of the examples I gave in the presentation was with a database. So most of the database vendors use this approach to give you an easy way to provision a database in your cluster. So for example, if you want to have PostgreSQL running in your cluster, you have a PostgreSQL operator and you have a PostgreSQL CRD. And when you create the CRD, the operator, based on some configuration in the CRD, gives you provisions a database for you in your cluster. And another thing is lifecycle management. We are using it on the project I'm working on. We are doing security for Kubernetes, and we have some components which are running inside your cluster. So we have an operator which provisions these components when you apply our CRD. So this operator is taking care of all the specifics of our components. So it does a lot of work in the background for you, so that you don't have to do it. And I think this is really popular for these use cases because it fits really well with the declarative nature of Kubernetes APIs, because it focuses on what you want and not on how you want it. And this is how most of the Kubernetes APIs work, and it fits really nice with them.
Okay. Many thanks, Anton, once again for joining us.
Thanks, folks, for having me.
I wish we have another opportunity in the future again. To the audience, if you have any questions that you would like to take offline with Anton, feel free to write comments, approach him in the social networks, or write a comment in his GitHub repo. What's coming next is half an hour break, and exactly at 3 p.m. Bulgarian time, we'll continue with the second half of our agenda for today. Thank you, Anton, once again, and for the audience, see you in half an hour.
Opportunity is everywhere.
This could be fun.
It's a door.
Ooh, it's doing a lot of kicking down there.
Waiting to be open. Whatever your ambition, whatever your drive, whatever you're chasing, opportunity is everywhere. All you have to do to find it is get out here.
We're a pretty resilient species, and that's true now more than ever. We're finding new ways to do our jobs. We're calling on old skills. We're turning closets into offices and kitchen tables into 4-star restaurants. And we deserve digital experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. These adaptable apps rely on agile technology and mindsets to make the development process seamless. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
We are Musalasoft. Our office is the whole world, and in it there are 4 physical locations, Sofia, Skopje, Russe, and Burgas, where we get together again more and more often. 6 values which unite us from anywhere around the globe. 650 plus impeccable professionals, redefining the laws of teamwork. Over 1,000 projects for more than 200 clients from all over the world. And countless meetings for a beer or two. In the mountains, the seaside, with family, kids, friends, pets, you name it, we go for it. The heart of Musalasoft is where each one of us works and has fun, learns and shares knowledge. From collecting chocolates, gadgets, dragons, fishing hooks, pots and pans, fitness weights, and even pictures from Turbo Bubblegum, to having kids, serving cats, raising dogs, fish, birds, and going on adventures. Together, we enjoy teamwork. We are innovation. We make an impact. We create with passion, respect each other, and deliver quality. We are Musalasoft.
We are Ocado Technology, and we have been transforming online grocery through technology and automation. We build cutting-edge solutions using artificial intelligence, machine learning, data science, robotics, cloud technologies, and even Internet of Things. And all of this innovation is born out of 7 development centers across the whole Europe.
The scale of Ocado's ambition is fairly breathtaking. So there's a sense of opportunity to learn, but to contribute and actually make a difference.
We've come from almost nowhere, and we found ways to solve problems that no one else in the world has managed to solve.
What I found it's unique in the Ocado culture is this passion.
The ability to experiment, to check new things.
You have the autonomy to go out and look for different solutions, new solutions. That's what the whole place is about. How can we do it better?
We created Indigo Design App Builder to accelerate your app delivery with one app creation platform. Now your designers, developers, and product managers can all work in the same WYSIWYG cloud-based platform. No need to download anything, no heavy IDEs or third-party dependencies, reducing friction and costly errors, and providing customers and users with better apps faster. Indigo Design App Builder includes a rich layout system and complete toolbox of real UI components and tools. Designers simply drag and drop actual components to build a real app fast, without the requirement of a vector-based design. With an integrated design system, you can easily create custom themes matching your product's branding. Get started quickly with a sketch file or use a pre-built app template. Deliver apps faster to your customers. Try Indigo Design App Builder today.
Accepting payments simply and securely is what we do. For 20 years, we've helped hundreds of thousands of businesses simplify payments with products designed for an evolving world. Our integrated payments technology is active in 120 global markets, and our payment methods are trusted by tens of millions of consumers. So whatever your model, size, or sector, plug into PaySafe to grow your business with confidence. If your business doesn't stay current, it can lead to frustration on all sides, and your customers have an ever-changing array of ways to pay: cash, card, via a digital wallet, or a bank transfer. We accept over 70 different payment methods, online, in-store, or on the go. And with our wide menu of tools, applications, and banking relationships, you can provide your customers a secure, instant, and personalized payment experience. Plugging into PaySafe means connecting your customers to the ways they want to pay.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained.
The Hershey Company is an organization that's driven to bring positive impact to the world. We have in excess of 80 iconic brands such as Reese, Kit Kat, Hershey's. Hershey's looking at how do we evaluate and manage the brands that we are delivering to ensure that they're profitable. So technology will help to bring a lot of that together, whether it's through how we actually process certain types of transactions, whether it's how we evaluate and manage the financial performance of certain brands or certain customers. The organization was faced with making a decision and moving directly to adopt SAP S/4HANA Central Finance. We see it already leading to quicker decision-making. We can do a lot of analysis on a brand, on a customer, on a specific cost center, as well as on vendor activity or customer activity. SAP was key to Hershey's overall success.
Smart IT е технологичното ядро за разработка и поддръжка на собствени комплексни бизнес решения на Management Financial Group. Български финансов холдинг в сферата на небанковите финансови услуги, опериращ в цяла Европа. Решенията, които Smart IT създава, подпомагат дигиталната трансформация на бизнеса. Днес звеното разполага с 130 специалисти, заети в разработката на ERP-системи, бизнес интелидженс, финтех платформи и още. Дейността на компаниите се разделя в 5 дивизионни направления. Дивизия Home Collected Credits има най-голям дял от групата с общ оборот от близо 140 милиона евро за последната година, с представителства в Централна и Източна Европа.
Казвам се Радостин Богдан. В екипа на Smart IT съм от 6 години. Нашите партньори имат нужда от решения, които позволяват лесно, бързо и гъвкаво да стартират и развиват бизнесите си. Гордеем се с най-мащабният ни проект – адаптивната финтех платформа SmartCheck, която им носи това конкурентно предимство.
Opportunity is everywhere.
This could be fun.
It's a door.
It's doing a lot of kicking down there.
Waiting to be opened. Whatever your ambition, whatever your drive, whatever you're chasing, opportunity is everywhere. All you have to do to find it is get out here.
We're a pretty resilient species, and that's true now more than ever. We're finding new ways to do our jobs. We're calling on old skills. We're turning closets into offices and kitchen tables into 4-star restaurants. And we deserve digital experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. These adaptable apps rely on agile technology and mindsets to make the development process seamless. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
We are Musalasoft. Our office is the whole world, and in it there are 4 physical locations: Sofia, Skopje, Russe, and Burgas, where we get together again more and more often. 6 values which unite us from anywhere around the globe. 650 plus impeccable professionals, redefining the laws of teamwork. Over 1,000 projects for more than 200 clients from all over the world. And countless meetings for a beer or two. In the mountains, the seaside, with family, kids, friends, pets, you name it, we go for it. The heart of Musalasoft is where each one of us works and has fun, learns and shares knowledge. From collecting chocolates, gadgets, dragons, fishing hooks, pots and pans, fitness weights, and even pictures from Turbo Bubblegum, to having kids, serving cats, raising dogs, fish, birds, and going on adventures. Together, we enjoy teamwork. We are innovation. We make an impact. We create with passion, respect each other, and deliver quality. We are Musalasoft.
We are Ocado Technology, and we have been transforming online grocery through technology and automation. We build cutting-edge solutions using artificial intelligence, machine learning, data science, robotics, cloud technologies, and even Internet of Things. And all of this innovation is born out of 7 development centers across the whole Europe.
The scale of Ocado's ambition is fairly breathtaking. So there's a sense of opportunity to learn, but to contribute and actually make a difference.
We've come from almost nowhere, and we found ways to solve problems that no one else in the world has managed to solve.
What I found it's unique in the Ocado culture is this passion.
The ability to experiment, to check new things.
You have the autonomy to go out and look for different solutions, new solutions. That's what the whole place is about. How can we do it better?
we created Indigo Design App Builder to accelerate your app delivery with one app creation platform. Now your designers, developers, and product managers can all work in the same WYSIWYG cloud-based platform. No need to download anything, no heavy IDEs or third-party dependencies, reducing friction and costly errors, and providing customers and users with better apps faster. Indigo Design App Builder includes a rich layout system and complete toolbox of real UI components and tools. Designers simply drag and drop actual components to build a real app fast, without the requirement of a vector-based design. With an integrated design system, you can easily create custom themes matching your product's branding. Get started quickly with a sketch file or use a pre-built app template. Deliver apps faster to your customers. Try Indigo Design App Builder today.
Accepting payments simply and securely is what we do. For 20 years, we've helped hundreds of thousands of businesses simplify payments with products designed for an evolving world. Our integrated payments technology is active in 120 global markets, and our payment methods are trusted by tens of millions of consumers. So whatever your model, size, or sector, plug into PaySafe to grow your business with confidence. If your business doesn't stay current, it can lead to frustration on all sides. And your customers have an ever-changing array of ways to pay: cash, card, via a digital wallet, or a bank transfer. We accept over 70 different payment methods, online, in-store, or on the go. And with our wide menu of tools, applications, and banking relationships, you can provide your customers a secure, instant, and personalized payment experience. Plugging into PaySafe means connecting your customers to the ways they want to pay.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained.
The Hershey Company is an organization that's driven to bring positive impact to the world. We have in excess of 80 iconic brands such as Reese, Kit Kat, Hershey's. Hershey's looking at how do we evaluate and manage the brands that we are delivering to ensure that they're profitable. So technology will help to bring a lot of that together, whether it's through how we actually process certain types of transactions, whether it's how we evaluate and manage the financial performance of certain brands or certain customers. The organization was faced with making a decision and moving directly to adopt SAP S/4HANA Central Finance. We see it already leading to quicker decision making. We can do a lot of analysis on a brand, on a customer, on a specific cost center, as well as on vendor activity or customer activity. SAP was key to Hershey's overall success.
Smart IT е технологичното ядро за разработка и поддръжка на собствени комплексни бизнес решения на Management Financial Group. Български финансов холдинг в сферата на небанковите финансови услуги, опериращ в цяла Европа. Решенията, които Smart IT създава, подпомагат дигиталната трансформация на бизнеса. Днес звеното разполага с 130 специалисти, заети в разработката на ERP-системи, бизнес интелидженс, финтех платформи и още. Дейността на компаниите се разделя в 5 дивизионни направления. Дивизия Home Collected Credits има най-голям дял от групата с общ оборот от близо 140 милиона евро за последната година, с представителства в Централна и Източна Европа.
Казвам се Радостин Богдан. В екипа на Smart IT съм от 6 години. Нашите партньори имат нужда от решения, които позволяват лесно, бързо и гъвкаво да стартират и развиват бизнесите си. Гордеем се с най-мащабният ни проект – адаптивната финтех платформа SmartCheck, която им носи това конкурентно предимство.
Hello and welcome back to the Ista conference. I'm Rado and I'll be the moderator for the second part. And I hope that you get refreshed and ready for the next set of sessions. So we are starting with Stani Grozdeva. She's a corporate development executive with more than 15 years of experience in advising Fortune 500 companies, and we'll talk about corp dev in the tech industry. Welcome to Ista, Stani. The stage is yours.
Thank you so much, Rado. It's a real pleasure. It's my first Ista conference, and I've been really looking forward to this. So a little bit about your speaker today. This is me in Sofia earlier this summer, and two of these kids are mine. The third one is my nephew. I started in the National Math and Science Gymnasium in Sofia. I hope some of you watching today are graduates of this high school. And today I'm at Invite. I'm in the corporate development team of this growing company in a growing industry. It's a company in the genetic testing space, in an industry, in an emerging industry called precision medicine. And I've been doing mergers and acquisitions for the past 15 years, as Rado mentioned, and I've worked on over 200 deals. Quite honestly, I don't even know how many at this point, but when you do multiple 10, 20 a year, it adds up. So the goals of the presentation today are to tell you more about the corporate development function in emerging or large companies, type of merger and acquisition deals, who are the serial acquirers specifically in the tech space and what are they looking for, and how do we source the deals? How do we find companies to buy? And what's in it for you? Maybe one day you want to start your own business and sell it. That's the ultimate goal, to sell a successful business. So how to sell your business? Before we start, I just wanted to set the stage with a little bit of background about the market pie. What exactly is the market pie? Think about a pie that's an industry in a country, or it could be global, but the market pie could be, for example, ERP solution, where Oracle and SAP play. It's a global market for ERP solutions. Or it could be local, for example, the red wine market in Bulgaria. And you have different players that hold a market share, so piece of the pie. If we go back to the example of red wine in Bulgaria, you have multiple big wineries and some smaller ones, and that comprises the red wine market in Bulgaria. The market pie can grow and slow its growth and even shrink over time. An emerging industry is something that grows really, really fast. I'll give you an example later on the social media industry. It didn't exist 15 years ago, and now it's a large pie, so it grew really fast. And once it matures, it doesn't grow as fast. It slows its growth. And at some point, it starts shrinking. So there are shrinking industries, let's say the tobacco industry is shrinking as the developed world cuts down on the use of cigarettes. So that's an important concept to understand why companies look to buy other businesses. And what is corporate development? People oftentimes think of corporate development as a software development type of function, but it's really not. It's a small team that reports to the chief financial officer or the chief operating officer and works with company executives to identify acquisition targets, sometimes partnerships, but most often companies to acquire. It also executes the M&A deal, works with lawyers and bankers to make the deal happen. And last but not least, it helps integrate the deal into the business and tracks performance of the acquired business. So sets goals for this acquisition and tracks it over time and ensures it's successful within the business. And what are common deals in the tech industry? There are many, many types of deals, but for the tech industries, I thought about what we see most, and really it's 4 major categories: to complement or add a product, take out a competitor, buy revenue and growth, and I'll talk about why that's important, or buy talent, just buy new employees. Add a product or complement a product. This one usually comes from the chief technology, chief product officer, and there's something missing and they want to add to the product to make it competitive, or to have a competitive advantage to the competition. So you tuck this in and improve your products. You might have a function internally that's building this, but it's always faster and better coming from a small and nimble startup. So you just plug this in. The other one that's fairly common is taking out a competitor. If we go back to the market pie, while it's growing really fast, there are multiple competitors and you're trying to grab as much market share as possible, the bigger piece of the pie you can get. And the ultimate goal is to gain that market share and consolidate the market power. And revenue and growth in growth industries, such as the one I work in right now, companies are measured by how fast their revenue is growing or how fast their user base is growing. And sometimes it's easier to buy ready revenue, these customer relationships, so that you show that upward trajectory. Because at the end of the day, your investors are not looking if you're growing organically or inorganically or a combination. They look at the whole bottom line. What's your revenue at the end of the year? Or the other one is buy talent. I'm not sure how it is in Europe, but in the United States, technology talent is hard to find and it's very competitive. So sometimes companies would buy small startups that have a constellation of machine learning engineers or bioinformaticians or PhDs of some sort. So buying this cluster of talent is also important. Those deals, by the way, are called aqua hires. You literally just buy a talent. You don't care about their product. So how do we go from an idea to a deal? And how do we source the acquisitions? So first, there's the one we know, and I'll talk about this in a second. The second most common one is setting your strategic priorities with management and the strategy team, and create an M&A funnel, potential targets that'll fill in the gaps. And the third one is just opportunistic. Sometimes an opportunity comes and you jump at it. The one we know would usually come from our chief technology officer, chief product officer. They would bring in the deal. We map out the potential M&A targets. And when the time is right, we start negotiations with the top few, and then eventually one will drop out of the funnel for this particular capability. And then the third one that's fairly common is the opportunistic one. We read in the news that someone is up for sale, or we see that they filed for initial public offering. We want to grab them before they're public and cost a lot more to acquire. Or we get an outreach from bankers or the management. They're up for sale. They're ready to exit. The investors are ready to sell the business. So that's when we engage in conversations. And even if we didn't plan on this acquisition, or it's not the perfect time for us, we go for it, because if we lose it, the opportunity is gone. And who are the tech serial industry buyers? Well, you have the big tech. They have deep pockets. Your typical big tech company buys 20, sometimes 30 businesses a year over year. Some of them are small, you barely hear about them, and some of them are large. And they all have corporate development teams, and some of them are so large that they have multiple corporate development teams for the different parts of the business. For example, Amazon has corp dev team for AWS and for the rest of the company. The other serial buyer is your emerging industry leader. So to explain why that's important, let's talk about this kids game called musical chairs. You have a group of kids, they circle around the chairs, but there are fewer chairs than kids. So at the end of the day, some kids will be left without chairs. It's the same with these market pies. You have an emerging market and it's growing fast. So you may have 10, even 15 players in there. But when the market matures and stops growing as fast, you're gonna have maybe 3 left. So who are these 3? And if you want to grab one of those chairs, you have to grow fast enough, faster than the market pie. So this could happen through acquiring your competitors or acquiring smaller companies to grab as much market share as possible. So these emerging industry leaders also acquire a lot of businesses in order to get there faster. It doesn't matter how much it costs. So let's talk about a little example that will be very relatable. Do you remember when Facebook bought Instagram in 2012 for $1 billion? This deal was unheard of. It shocked the financial world. It seemed so outrageous at the time. Instagram had 13 employees and no revenue and no plans to make revenue. 13 employees, $1 billion. And that's almost 10 years ago, so it cost much more. And at the time, Facebook's revenue was $5 billion. So it did sound crazy, right? But that market grew so much. Think about the social media market and the advertising revenue they're bringing in. Who could have imagined back then that Facebook will find a way to listen to your conversations, look at what you're browsing on the phone and your laptop, and then sell this data to advertisers. And on top of that, sell them advertising services and making so much money. So today, Instagram contributes 25 billion in revenue to Facebook, has 1.2 billion daily users, 1.2 billion. And if it's split from Meta, it'll be valued at $400 billion today. It's actually considered one of the best tech acquisitions of all times. Then the next year, about 14 months later, Facebook offered $3 billion in cash to a couple of college dropouts to buy Snapchat, one of their emerging competitors. They're trying to get that competitor and get the bigger pie, right? Well, they declined, which also sounded kind of crazy at the time. But today they're valued at $88 billion. And that's only because their share price tanked over the last few weeks. It was north of $100 billion. So clearly they did the right thing. And just a year later, so just this is how fast this pie is growing. So the financial world started to realize the potential of social media, right? In 2014, Facebook bought WhatsApp for $22 billion. So they go from $1 billion to 3 to 22 in a matter of less than 3 years. And today WhatsApp has 2 billion daily users. It's again an incredible amount of users. And why are the tech valuations so high? Before tech arrived, valuations were based on profit, and the growth was very modest. 5, maybe 10% a year was considered good growth. And then you have tech arrives, and you have valuation based on revenue multiple or growth of user base. No one is even looking at how much the company is making. Well, tech is different. There are no physical constraints. You don't deal with supply chain. You don't deal with manufacturing, with parts. Everyone knows about the supply chain issues right now. Well, tech companies are not bothered. They just continue to sell their tech products. It's a reusable product. You make it once and you sell it to many, many other businesses or users. And especially for software as a service, you have the recurring revenue. You hook them once, you sell one time, and you have many years of recurring revenue that usually grows over time. And it's all high margin revenue. And also there's the unlimited technology possibilities. Technology continues to amaze people in the financial world at how you can innovate at scale and come up with solutions that weren't even conceivable 10 years ago. So what are we looking for in an M&A target? We want to see product quality and potential, the talent, that's very important, the caliber of the employees and how similar is the culture. If you have a group of PhDs that'll be really hard to work with, it's probably not a good fit. They'll leave or they won't work well with the company, so talent is very important. And also the timing. It's all about the timing. As I mentioned, the companies are very deliberate at what exactly they're buying and when. So let's go back to the most important question here. A lot of you are probably thinking, hey, how can I start a company and sell it? That's really the ultimate goal one day for a lot of entrepreneurial engineers. So what do we need to do? Build a quality product that fills a market void, something that hasn't been done or it's not done well today. Show revenue growth or user growth. So once you have that product, show how fast you're growing. That's very important. Partner with your potential acquirers. Remember, we talked about the trusted, the one we know. And market your business. Get out there and get that press coverage, get in the tech publications, get in the mainstream media, blogs, get people to talk about your business, and go out there and go to industry conferences, make yourself known. Marketing yourself is very important here because no one will notice if you have a great product, but you're not out there and market it. And last but not least, network with your potential acquirers. Some of the companies we buy, we talk to for years prior to that. We're courting each other and we know that one day a deal is very possible, but it's a long process. So network with your potential acquirers and develop these relationships. And with that, I will turn it over to questions if anyone has questions about this process.
Thank you, Stani, for this talk. It was really, really interesting. And to be honest, actually, I have a question. And this question is, what is the best time to sell a startup?
The best time, so depends on how developed your company is. But I would say when you're growing really, really fast and you can show that growth and you can see that, it's maybe it will start to slow down in a little bit. You want to see that multiple that's really fast growing. That's a good time on the cusp of getting more mature. Once you get more mature, you're losing that value. Or if you have investors, they will advise you, and investors want to see 3 to 5 years of return, so they will push you out at some point and sell you. But don't sell when you're frustrated because some deal fell through and you have one roadblock. No, just look at it as a big picture. There's a good timing to sell.
Okay, and when I get an offer for my startup, how do I know if it's a good deal or if it's undervalued?
That's a tough one because with the private businesses, the values are typically not disclosed, the values of these deals, unless there's an investor. That's when they'll announce that they exited at this much money. So look at comparables in your industry or similar industries and look at how much they sold for and try to get your own valuation to make sure that you're not undervalued. Because especially some of the more seasoned venture capitals or private equities, they'll try to lowball these companies. Lowball meaning offering less than what they're worth. So you need to know what you're worth and do your own investigation.
Okay, and we have another question. You mentioned companies with a lot of PhDs. Does it mean that having a company with PhDs is actually a bad target?
No, not at all. Sometimes we want this company for the talent, but also you want to make sure that they can fit in the acquired company and they won't leave the first year because they're frustrated. So PhDs is very, very valuable. As I mentioned, talent is one of the things we look for, but also cultural fit is important.
Okay, and I think that we have one more question, time for one more question. What are the associated costs to sell a startup? Who do I need to get involved in it?
Yeah, so if you're at a point where you want to sell your company, you got a compelling offer, get a good lawyer who specializes specifically in these kind of deals, get a banker or someone to represent you. And it doesn't have to be a big bank. If it's a smaller team, if it's a smaller business, you can get someone who's done this before, work for VCs. Make sure that your financials are in order. So that's going to take a little bit of time, maybe get audited. That's always a plus. So that's another cost. So lawyers, bankers, accounting services, tax services, get your house in order and ready to sell. Those are your biggest costs. And if you can find an advisor to represent you, to make sure that you're getting the best out of the deal, that's something else that it's really worth investing in.
Thank you, Stani. This was really, really useful and interesting. I hope that next year we will have you in person in Sofia for the Ista.
Thank you so much. Thanks so much, Rado. It was my pleasure.
Okay, here we go, guys. Ready? Cinturones, por favor. Gracias. Opportunity is everywhere. This could be fun. It's a door.
Ooh, it's doing a lot of kicking down there.
Waiting to be open.
Whatever your ambition, whatever your drive, whatever you're chasing, opportunity is everywhere. All you have to do to find it is get out here.
We're a pretty resilient species, and that's true now more than ever. We're finding new ways to do our jobs. We're calling on old skills. We're turning closets into offices and kitchen tables into 4-star restaurants. And we deserve digital experiences that are as resilient as we are. This starts with apps that can scale to keep pace with shifting demand, or update at a moment's notice to support entirely new business models. These adaptable apps rely on agile technology and mindsets to make the development process seamless. In a time when the app experience has become the human experience, being future-ready means keeping people at the heart of innovation and flexing to meet their needs. Because technology really can change the world, but the best technology changes with it.
We are Musalasoft. Our office is the whole world, and in it there are 4 physical locations, Sofia, Skopje, Rusa, and Burgas, where we get together again more and more often. 6 values which unite us from anywhere around the globe. 650 plus impeccable professionals, redefining the laws of teamwork. Over 1,000 projects for more than 200 clients from all over the world. And countless meetings for a beer or two. In the mountains, the seaside, with family, kids, friends, pets, you name it, we go for it. The heart of Musalasoft is where each one of us works and has fun, learns and shares knowledge. From collecting chocolates, gadgets, dragons, fishing hooks, pots and pans, fitness weights, and even pictures from Turbo Bubblegum, to having kids, serving cats, raising dogs, fish, birds, and going on adventures. Together, we enjoy teamwork. We are innovation. We make an impact. We create with passion, respect each other, and deliver quality. We are Musalasoft.
We are Ocado Technology, and we have been transforming online grocery through technology and automation. We build cutting-edge solutions using artificial intelligence, machine learning, data science, robotics, cloud technologies, and even Internet of Things. And all of this innovation is born out of 7 development centers across the whole Europe.
The scale of Ocado's ambition is fairly breathtaking. So there's a sense of opportunity to learn, but to contribute and actually make a difference.
We've come from almost nowhere, and we found ways to solve problems that no one else in the world has managed to solve.
What I found it's unique in the Ocado culture is this passion.
The ability to experiment, to check new things.
You have the autonomy to go out and look for different solutions, new solutions. That's what the whole place is about. How can we do it better?
Well, our next speaker is Daniel Rankov. He leads the Cloud Center of Excellence at MentorMate, and he is actually a co-organizer of the AWS Bulgaria user group. He was recently recognized as the first AWS community hero in Bulgaria. Daniel, welcome to Ista. The stage is yours.
Hello, and my pleasure to be here. Thank you very much. So today I'm going to speak about adopting DevOps practices to achieve security and compliance. So a few words about myself. Thanks for that introduction, Rado. Yes, even though that I'm at the manager position, I'm still a very hands-on person. I have 8 active AWS certifications, and I do hands-on work myself as well. I'm also a trainer for AWS training, and I do DevOps training for Telerik Academy as well. And something that I'm very proud of is the AWS Community Hero part, because this is a group of people which is below 250 around the globe. So definitely very proud to be one of that awesome group. Moving on. Now, when it comes to regulated industries, and I've listed just a few here, we see multiple challenges in that fast pace of iteration. Now, DevOps brings a lot of automation in the software development lifecycle, and we are used to these fast feedback loops, fast delivery streams. But when it comes to regulated industries, and when it comes to security and compliance, we might see some blockers along the way. And let me guide you through that part, how we manage to move these blockers and still keep the fast pace of software delivery. I'm going to review 2 big topics today. One would be the infrastructure, and the second would be the application front. And now, when it comes to infrastructure, how do we address the need to produce secure and compliant infrastructure? Now, in the old days, when we needed to create infrastructure, let's say virtual machines or some object storage or a relational database or maybe some analytic services, we needed to go and then click here and there to start a virtual server. So it used to be a very manual process. Nowadays, if we think about how we operate with both public and private cloud vendors, is that they provide an API so that we can, in an automated fashion, create infrastructure. And this approach is known also as infrastructure as code, so that we treat the infrastructure in the very same way as we treat our application code. We keep it into a version repository, we do peer reviews, and that all happens even before we start creating that infrastructure. Let me review some of the benefits of the infrastructure as code. Now, obviously, if we keep our infrastructure in our version control, let's say Git repository, well, it's auditable, right? We can trace who, when, and what was changed. We have a full audit log of what has been changed. Another key aspect of the infrastructure as code is when we execute this creation process, well, it's a consistent one. We have already defined all of our resources as code. So think about the difference. If we need to create, let's say, tens of environments through infrastructure as code, it will be much consistent than having a person going through a checklist and creating them all manually. Obviously, as we keep our infrastructure as code, it's well documented as well, because it's there in the Git repository. Now, why we say that it's even more secure than the usual approach? Well, we can do peer reviews even before we start creating this infrastructure in production, so that we can apply even automated security checks as part of our delivery pipeline. And here I've depicted just a standard delivery pipeline where we have the code and we want to deploy it. Now, if it's a if that process is automated, right, as a pipeline, we can review, we can do the peer review, we can apply automated security checks, and then we can approve that and deploy to production. Now, think about some of the tools that can help us achieve all that are just Terraform is probably one of the most widely used tools to achieve that. And tools like Chekhov or TFSec can help us and can be implemented as part of our delivery pipeline. so that we can have automated checks. And again, think about how awesome that is. We get to know that we are about to deploy a non-secure environment, right? So we catch that even before it goes to production, and that is awesome. Now, I would like to share how the public cloud can also help us achieve our high security and compliance standards. First, the data topic. Obviously, it's gaining more and more traction. We see more people streaming, gathering, and then analyzing data. This is a screenshot of the AWS region map. And all of these are regions, so that means stacks of data centers across the globe, so that when we want to deploy our application, either based on latency, to be close as possible to our users, we can also choose where to reside based on our compliance regulations. Right, so that if we want to be GDPR, we can keep the data in Europe and then build a, let's say, primary region in Ireland, and then build a disaster recovery region in Frankfurt, right? If we want to comply with California Protection Act, well, we can deploy in US. So that's one way that the public cloud vendors can help us achieve our data regulations. Another way that the public cloud vendors can also help us achieve secure environments is by them providing the so-called reference architectures. Now, this is just an example of the AWS HIPAA guide on how to deploy HIPAA and high trust, which addresses the healthcare domain. And we can use that as a guiding light. Even if we don't use or reuse it as is, we can just use it as a guiding light. We can see that also the public cloud vendors provide infrastructure as code. So we can take that very same code, modify it based on our own needs, and then achieve the framework that we are targeting. Probably one of the hardest things to achieve when it comes to compliance frameworks, and I don't want to dive into the details here, I just want to use that as an example, is probably that at the left-hand side, we see all that security controls, and I have chosen the HIPAA control checklist here. When we think about how the public cloud vendors can help us, is by them providing a mapping between the security controls of a framework and then the actual tool chain or set of services that can help us achieve all that. And that saves a tremendous hours of time. And if you have that need, please consider reviewing that security control matrices based on the compliance framework that you have to achieve. Now, another way that the public cloud can help us is through managed services. And I have taken an example here about a relational database. Think about it. If we have to manage a relational database in our on-premises data center, well, we are responsible for all of the for every layer in that stack. So we need to rack and stack the servers. We need to maintain the hardware there. We need to install the operating system, then patch it, then install the database, then patch it, then create the backups and scalability and high availability, which is not usually a very trivial thing to be done. Now, if we consider the picture of the right-hand side, we can see that just a few layers are handled by the public cloud vendor. Now, think about it. We are using, let's say, in this case, AWS, and we start a virtual machine, and then on top of it, we start deploying our database. Now, if we just look at the layers, at least a few of them are now responsibility of the public cloud vendor. So when we have audit, what will happen? Well, the auditor will only audit us at the the top right layers. Everything else would be responsibility to the public cloud vendor. And now think about it. If we are using a managed service, a fully managed service by the public cloud vendor, now every layer except the application optimization is managed by them. So when you have an audit to be performed on your infrastructure, well, it's them, it's the public cloud vendor that will be audited. So that saves tremendous hours of time. So when we consider would one service be cheaper or more expensive than another, consider that these services that the public cloud vendors provide, they have already passed multiple compliance and regulation audits. And I've provided here just a few of the compliance regulations that AWS is part of. The majority of services in AWS have already passed the ISO standards and PCI DSS if you work with credit cards, and the SOC levels as well. But if you work with the government, maybe FedRAMP is what you want to address. And then also in the healthcare domain, we see HIPAA and HITRUST. And these are just a few. We can also see multiple regulations and compliance programs in the fintech industry and a lot more. Here I've provided just an example of the clients that the public cloud vendors have, and in this case, AWS. So if NASDAQ is using it, and then Robinhood is all in AWS, and we see banks fully using all in the public cloud, and governments using the public cloud. We see companies in every business vertical adopting the public cloud. And sometimes I hear, well, public cloud might not be as secure as I want it to be. And please consider reviewing this testimonials page if you still consider that. If it's secure enough for NASA, and if it's secure enough for CIA and the Department of Defense, it's probably secure for your business as well. Now, the second topic that I would like to address is the application code and our source code. Here, I'd like to quote Gartner, and they say that security and risk management leaders can meet tighter deadlines and test more complex applications by seamlessly integrating and automated application security testing in the software delivery lifecycle. They've produced a report earlier this year. I've left a link to the resource page so that I will leave for you to see the details there. But what are the application security testing tools and the tool chain around that? I would like to quickly review these. Again, I've depicted at the bottom just a standard pipeline where we have build, test, and deploy phases. But then if we want to start automating the security part, how do we do that? Well, first, we can implement the static application security testing, or so-called SAST. It looks very much as the standard static code analysis. It reviews, the tool chain reviews our source code, right? And then provides us feedback. And some of the software vendors of these tools provide even integrations with our IDE. That means that we can get that fast feedback loop really, really fast. We can see that there is a vulnerability in our code as we write it. So that is one option here. A few tools that I've mentioned here, and of course, please consider reviewing the Gartner provided ones here too that are not represented there, but are valuable tools. Now, the second approach would be the so-called dynamic application security testing, and to an extent that very much looks like a penetration test. So we do a scan of our code security after it has been deployed, and we can deploy it to an internal environment, scan it there, and then move it forward in the pipeline. A few tools that exist in this context is the OWASP ZAP project, then Burp, and of course the Kali Linux comes with also a lot of handy tools to achieve that. Then interactive application security testing, that type of tools operate inside our application and can detect vulnerabilities as we test it. Also something that we can implement as part of our delivery pipelines. Now, if we think about probably the last stage, we have deployed our software in production. It now serves production traffic, and we see happy clients. Is there a way for us to implement security even at this layer? Well, there is. It's known as RASP, or Real-Time Application Security Protection, and it generally works as a wrapper of our application. So every query that has been sent to our application first gets scanned, and then if our software says that it's safe, only then it's being sent to our to the application that we write. Now, when it comes to software dependencies, our software is as secure as our dependencies are, and this is known as a software supply chain management. Our software represents a set of obviously the source code that we write, so there's a first-party code, but then also the libraries that we depend on. Let's say the database connector or our WOC management solution. So that we almost always use third-party code, so that in order for us to know that our whole solution is secure, maybe we need to scan that dependencies as well. And here I would also include the operating system, maybe in the form of a container, but it's also a layer in our supply chain management. How do we address that? There is a set of tool chains which are known as SCA software composition analysis, which helps us track and analyze third-party components or open source projects. And we can, these type of tools usually can even scan an open source project if we are using a project and we do not comply with the license of the open source project. So that's also important for us to know. Just a few examples. Here is the OWASP dependency checker, and we have SNCC, which gains a lot of traction nowadays, and a very simple tool, even like an NPM audit, also can be used. Now, the general approach is how to start. Well, just start small. Okay, start with one simple check, then add until you have that whole holistic picture of security. And all of these tools can be integrated with our delivery pipeline. So we have that fast feedback loops. We know that our software and the dependencies are secure. Now, it won't be a DevOps talk if we don't address the cultural aspect here. Yes, when it comes to implementing security, and we need to achieve that high compliance bar, well, the usual advice is, hey, let's sit together. Let's sit on the same table with everybody who has something to add. Break that wall of confusion, the so-called wall of confusion, and just work together. Because in the end, we all want the same thing. We all want functional code, which is also secure. That's a favorite picture of mine. I'd like to depict that, yes, let's just work together even more and not be the people at the top right corner just saying, well, that's not really my problem. The three resources that I'd like to recommend is the Unicorn Project, Accelerate book, and Ahead in the Cloud as well. I've left additional resources here so that if you're interested, please consider reviewing them. And then if you'd like to continue the talk, please do find me. And I'm very open to community and society as well. Yes, so you are welcome to also our gatherings of the AWS user group. You can find us on the meetup.com. And the next time we will speak about FinOps on AWS. So you're all invited to join. Thank you. And now I'm open for questions.
Thanks, Daniel. Really impressive. And I have this question. What was the most challenging part of this journey, actually? From your point of experience?
Right. Well, definitely working in a service company, we implement these solutions for multiple clients around the globe. And I would say that maybe when a person does that for a first time, that's really challenging because you're kind of lost. You don't know where to start. But then once you do, every project from now on, it's just easier. It's more structure. It's just well, you follow the same pattern, and that's just a general advice for a service company. Build that intellectual property inside that company. Knowledge, share these. As the public cloud vendors share with us these reference architectures, well, we can also share them and build our own internally. So that's a way for a company to scale in that manner.
Yeah, we have a question from the audience. In which stage we have to implement security validations from non-functional testing, like penetration testing, and how we can do this in order to achieve end-to-end automation?
Right. Well, as every consultant in the world will tell you, it depends. Right. It depends on your business needs. I've worked for projects and we've implemented projects that we had that security guardrails right from the beginning. So we did not even have functional code, but we had all of the security tool chain implemented. So that we know that no matter what the features are, we know that the software is secure and it complies with the regulations. And it's easier if we try to retrospectively implement security. It usually creates a lot of hustle. I'd have to tell you, probably you would need to break the whole infrastructure and then recreate it. And just a very simple example is if you create your whole infrastructure and you're happy with how it functions and everything was tested, and then you find that you don't do encryption at rest, so that your volumes, your storage, your object storage, your databases are not encrypted. Well, in some cases, you need to recreate all of that. So you first need to destroy it and then recreate it. So that kind of implements a lot of hustle. So again, it depends. I would say that it is a business decision on when to do it. The earlier, I guess, the better.
Yeah, definitely. But from another point of view, talking about DevOps and culture, how this is accepted by the team? How do you explain to the engineers that they have to take care for this from the very first stage of the development process?
Right. Well, as the DevOps mantra, it would be just culture. We should over communicate all of these. Again, otherwise we might end up with frustrated teams and teams that say, "Well, we've built our software, it's running, it's well running. Why it's not passing these checks?" So the earlier we implement it and the more automation we create, just the better. But then again, in every DevOps conference, for all the big companies, they say they have these 5-year plans of how to implement DevOps culture within the company. Their general advice is over communicate. Just speak more about the issue and address it, and of course provide well documentation, single source of truth.
Yeah, I'm asking also because there are some cases when at some stage the OSS check pass, but at some stage we found a new vulnerability, and for some reason, and for this reason, the pipeline fails. So this is something that I haven't introduced, but for some reason, I have to work once again on my project to fix this issue.
Absolutely. Fast feedback loops. Again, we are all in the same boat. It wouldn't matter if it's my fault or my colleague's fault. We are in the same boat. That's kind of my approach, at least.
Okay. Thanks, Daniel.
Thank you very much.
It was great.
My pleasure. My pleasure.
Thank you.
Thank you very much. Говорим, да, все прекрасно,
Okay, our next speaker is Javier Campos. He's the head of the Experian Data Labs for UK and EMEA. And he's actually a frequent speaker at the industry conferences and has more than 28 years of experience within finance, artificial intelligence, market research, media and technology fields. So welcome, Javier, and the stage is yours.
Thank you very much. Good afternoon, everyone. As I said, my name is Javier Campos. I head the data labs within Experian UK and EMEA. And just to describe what the data labs are, it's a bit like the R&D part of Experian. So my team job is to create the next generation of products. Today I'm gonna, so part of my job is to constantly be looking at the new technology, new developments on pretty much the industry, society, and see what can actually be applicable to, in this case, the Experian or the financial services industry. So today I'm going to talk a little bit about quantum computing and give you an overview. Very complex topic, but it's fascinating, and it's been recently on the news, so hopefully quite topical. So if I start on the deck, let me see. The first one, you can actually see the agenda. So we're going to go very quickly about what is actually a quantum computing. I'm going to also tackle at the beginning quite a few myths, and probably if I ask some of you, you might have heard from the news some things, but just to say what is true, what is not true. Then we're going to go into the detail. How do they work? Then I'm going to talk a little bit more concrete into what is going on in the industry, the ecosystem. Believe it or not, you can today program a quantum computing. They got their special programming languages. They're actually also available in the cloud for some computers, so you could start today. And finally, we'll touch a little bit of the applications, and you can see why for some areas this is a big topic, but some areas, and you will see this is part of the topic. So the first question is, what is a quantum computing? And this is when some of the misconceptions actually start. People say, oh, quantum computing is, you will see there are some definitions. It's a machine that uses property of quantum mechanics, quantum physics, to store data or do computation. Why is a bit misleading? Actually, any computer you have there, not just on your phone, on your car, on your laptop, and they use transistor, and transistors actually, for those that know a bit the electronics, use something which is called the PN sort of junction, which use quantum tunneling. So actually, all our computers, even our mobile phones, even any these days any appliances, even your washing machine might actually be a quantum device. So it's a bit we need to be a bit specific. So what a quantum computing is not just using quantum effects. As I said, all computers that have any transistor will use it, but specifically the way they storage and process information. And they use what we call qubits. And this is the critical thing for a quantum computing. What is actually in a normal computer, which I'm sure you all know as developers, actually the binary, the bit, which is the smallest unit of information, can contain 0 or 1. By doing this, then you scale, you create all the gates that do some processing on the information, and then you build our current generation of computers. Quantum computing is very different. The way they store information, and that's where the magic actually lies, is actually, it can as well be 0 or 1, but it can also be something in the middle. So for example, if you were compared to a switch, a light switch, a normal computer will be a switch that you move on and off, versus a quantum computer is like a dimmer, can actually be in the middle. And that creates quite a lot of interesting things. So the first thing is quantum computing, it actually stores information in qubits. Now, this is the important one, some of the myths. The first one, people are saying, and even the press get this wrong, by the way, which is quite embarrassing. And I saw an article in the New York Times, which I think they changed it. But first one is quantum computer and very fast classical computers. That actually is false. In fact, for many operations, a quantum computing is much worse than a normal computer. Anything that requires a lot of I/O, quantum computers are really bad at that. And a classical computer will outperform it. So that's false. Second one, quantum computing means the next generation. So once the quantum computers are working, the current generation is not going to be around. Well, this is also false. Why? Because quantum computers, and you will see, they do certain things very, very well, but not everything. And it is very likely that in 10, 20, 30 years in the future, you will have both types of computer, classical computers and then quantum. Next myth, quantum computing will destroy cybersecurity. And this is where people say, oh, once you have a quantum computing, you can actually break any website in seconds, any Visa encryption, whatever, HTTPS, which is based in a RSA sort of type of algorithms, can be cracked with quantum computer. This is a bit both true and false. It is true with a quantum computing, you can actually break any encryption that today, if you look at today encrypting and you get a very long key, like 1,000 bits or 5,000 bits, a brute force, a normal computer will take many years to break it. A quantum computer can break this very quickly. So it is true that a quantum computer will break the current cryptography, but it's also true that you can introduce new cryptography that will substitute. So effectively, yes, you can replace the legacy one, and once quantum computing are available, RSA algorithms will stop being used because they will be break very quickly, but there are already things either using quantum or not that cannot be there. And you will see why that's the case. The next one is, a myth is what people are saying are going to be there in the next 5 years, 10 years. If you talk to the vendors, they will tell you next year. Well, the point is, we don't know. Actually, it is quite interesting. IBM just announced a couple of days ago that they released the 127 qubits, which is a big deal because with that sort of level, until then, only the biggest quantum computer had about between 50 and 70 qubits. Going to 127, which is actually double, that's starting to get the scaling. And what is exciting is, as you know, because computing the way it works, it's going to scale. You need, for a practical computer, 1 million qubits, by the way. So you still far away, but actually, because of the exponential, we're not going to need 10 years. If we keep, and this IBM announcement is a bit surprising. It was a bit earlier than expected. So if this keeps going the way it's going, we're going to have a quantum computing available in a few years. The next one, which is a bit for these Marvel fans, quantum computing worm, whatever. And if you actually do a bit of a search, there are quite a lot of stuff on the web. People are putting, you can use to do time travel, synthetic consciousness, a lot of weird things. And actually here is unlikely, but not quite there. Quantum computing and quantum mechanics is quite strange, and you can argue we still don't control. So what is possible is there. So this is the next thing is quantum supremacy. You probably saw that happen last year when there was a lot of, what is the quantum supremacy? Is when a quantum computer can perform an operation much faster than a classical computer. That was achieved, it was a bit controversial, by the way, but it was sort of achieved last year. Google claimed they did it. IBM published a paper saying, well, you sort of cheated. They say, well, this computation, a classical computer would take 120 years. IBM came, actually, you can do it using other method in 3 days, something. So not quite supremacy. But the point is, and actually, that was with 50 qubits. With 127 qubits, that is now absolutely out of the question. A quantum computing for a specific type of problems can massively outperform classical computers. And you can see here there. So why does it work? Well, at the heart of why this, the quantum computer does all these amazing things and you will see I make a lot of points only for a specific type of problems. Quantum mechanics, the way it works is the measurement problem, which in quantum mechanics, you have every particle in the universe have what is called a wave function. The wave function is something linear, is something that the mathematics works, evolves to certain evolution. But then what happens is when you measure, the whole thing collapses into only one. So effectively, before you measure, you only have probabilities. This is very, very weird because in classical mechanics, if I throw a ball, I know exactly the position of the ball and the speed at every trajectory of if I fire a rocket. That's in classical mechanics. Quantum mechanics doesn't work like that. If I throw a ball, I will know the probabilities. And by the time I measure in a specific point, then the function will collapse and I will change, which is actually quite mysterious. We don't know why it happened or Why not? We just know that it works and it's been very successful. So one is the measurement problems. The second one is the superposition, and this is also very, very weird. So if you throw a single particle like a photon, you throw them in, and there are two slits very close, you throw them one, and they actually show interference pattern, which is the same you do with wave. Why this is weird? Because actually that happens if you shoot them one at a time. So you shoot one. All of them show like they interfere each other. This is quite strange, and we don't have time to go into the detail explaining. This also provide, well, you probably heard of the Schrödinger cat, that a cat is dead and alive at the same time. This effectively what happens is, which is the superposition. When you have two functions, and if you remember what I was saying, when I throw a ball, I don't have the specific function that said that's the ball. In a quantum ball is not like a normal ball. It's got a distribution. It could be in a number of places, and it could have a number of speeds. It's like a distribution globally. On the Schrödinger equation and the paradox is you put a gas in a box, and then you sort of get something to decay, a reactive material, which a half-life, which might or might not decay. You don't know. And the problem is, quantumly, from the quantum point of view, the cat is half-dead in a life, and you only know when you open. When you open the board, then you collapse because you measurement, and remember the measurement problem, and then things take one thing or the other. All very strange, and there are few interpretations, some of them the multi-word, but we don't have time to go that. And for me, this is the really weird one. This is the one that actually Einstein got wrong, which is the entanglement. And this actually, I think, is one of the key there that is going to make the quantum computer so powerful. So what happens is you get two particles, you actually get them in sort of sharing the same state, and then you send them away, and this is the key there. You send them many light years away, and then you measure one. When you do that, immediately the other will change. But the amazing thing is that doesn't happen. It only happens when you measure. And because if you send them very far away, that means that the information or whatever is happening travels faster than light, which it could not happen according to Einstein theory. So again, really fascinating thing, and you can have some graphics there. We don't know why it happened, but we know it actually happens. So this spooky action as a distance, that entanglement from particles can actually be used also in quantum computing. So how do they actually, the quantum computing works? And without going in a classical computer, when you do a calculation, the computer has to do every calculation at the same time. In a quantum computing, that's not the case. What happens is, because of you create these probabilities and these, so the information is stored in the qubits. Remember, the sphere is not just 1 or 0, it's a vector. And this is the trick. That vector can be negative. And so effectively what happens is, when you calculate the potential solutions for a particular problem, a quantum computing, these amplitudes, sometimes they interfere each other. And when that happens, what happens is, a classical computer has to perform all the calculations and have to do it. So it will take these hundreds of years. But a quantum computing does this interference and cancellations, and you will see there. And that's how it actually can come to the solution faster, because these probabilities, again, a negative probability, classically don't try to understand it, but the point is it gets there. And if you only remember one thing, is this one: quantum computers are not faster in terms of quicker than classical computer. What they do is, for certain type of problems only, they do the calculations they get to the solution much quicker, because they can interfere. They can do interference between all these solutions, the same as, if you remember, when the photon was sending to the two split lines, here is a similar effect, and they get to the right position at the much quicker. So how to build, and I'm going to accelerate, I think I'm running a bit late. This is, again, I could spend hours. There are many ways of doing it, and there is at the moment a really race, and actually the military is involved, so the US, China, and people are backing different technologies. Some people are doing it using trap ions, which is the one that you see at the top. IonQ, I think, is the only one that is in the stock market, if anyone wants to take a look at that. And they are doing quite well. All these things have pros and cons. So one is trap ions. The one that Google and IBM use, this is superconducting qubits. The problem with that one is you need very, very low temperatures, close to 0 Kelvin. So effectively, when you see the pictures on the news, is massive. Then another way, which is using photons and light, and this is using lasers, that the advantage for that, you can do lasers at room temperature, which is great, but the size is astronomical. So for example, China is doing that, and they just announced not long ago, like a computer doing 60 qubits with that one. Why is so challenging then? Why could we can do one? Well, the main problem is when I was explaining about all this magic of quantum physics, why don't we see that in reality? I was talking about a ball, but when you throw a ball, the ball, then they are in a single state, you can measure the speed there. Why don't you see? So we don't see quantum mechanics in real life because there is something called decoherence. When all this entanglement and all these things I mentioned, when you get a normal temperature, all these things collapse and they don't happen. For these things to happen, it has to be very, very specific condition. And to do that is very difficult. That's why the quantum fault tolerance is quite tricky. So there are enormous engineering challenges to build these things. And to be honest, the fact we have 127 qubits already is incredible. So these things, fault tolerance, recurrence, really difficult. So in terms, what I said before, actually you can already, there is a quantum computing marketplace. Your favorite software cloud, if you go to Amazon, you go there to IBM, to Google, Microsoft, they all have some sort of quantum cloud that you can actually get and book some jobs in a quantum computing. You need a special programming language, which is, you have to use, in the normal computing, the way you can do a program language that eventually is a compiler and gets to effectively switching on and off the gates at the and or and all this. Quantum computing, these gates, you have to, at the moment, the programming languages are a bit more complex and the algorithms are a bit more complex, but this will get like the same that happened at computing, So, there's what is some of the last developments. One of the things I just wanted to, and this is again, is being shown quite quickly, is a time crystal, which, if you follow Star Trek or Marvel, some movies, they do it, but actually they exist in reality. This has been a shock for all the community. What is a time crystal? Well, they're saying if you look at a crystal, is called regularity in space. So a diamond, you look at diamond and the atoms are structured there. They're saying a time crystal has the regularity over time. There are many, many implications, fascinating. We can use them. Okay, I'm gonna accelerate very quickly because we're running a bit late. So this is the key there is from all the potential problems where we can actually, and you can, here, this is the mathematical, the NP complete problems really hard, the P, which is what most computers can do this very quickly. So we think quantum computing can do much more than computers, but for example, factoring is included, but we don't know how much. And also, there are many problems that quantum computers don't do better than computers. There are some things here, for example, which computers can run very well. So the point is, a quantum computer will not have any advantage over a classical computer, and that's the point. So the first, just there. So what are the potential, some of the first application in cryptography is an absolutely good one. You could actually you will need to create a new type of cryptography because, as I said, anything that is based in RSA, which is based in factoring, a quantum computer will break instantaneously. Then two things in medicine, this is why pharma is putting a lot of money here. You can use this to simulate a quantum system, which guess what is what the drugs are. So that's what they will do that, machine learning, and then also searching some of the type search. So three things very quickly, and then I will leave some time for questions. What are the things you can take from the section? The first one, where are we in the quantum computing journey? Very, very early days. If you think about in the 50s, the first computer, in the 40s, which were ENIAC or the ones in the UK, there was a massive room and the processing power was pathetic. This thing will take 30 seconds. Well, at the time it was amazing. Look, this room full of devices can do what a human in 20 hours. That was unbelievable. Quantum computing is the same, but then you look at how this evolved. Now all this computer power, you have it much more in any iPhone. And not only that, if you look at the faster computer today, which by the way is a computer in Japan called Fukayo, have 442 teraflops, which if your computer is absolutely amazing. So you can see the computer is going to have the same evolution. When you see the current computers now, they are ruined, massive, expensive. They have a lot of errors, the same as the early ones. We will have them, and what will happen in the same time period remains to see. Second one, and please take away, because this everyone, especially journalists, get it wrong. A quantum computing just doesn't do things in parallel. No, that's not the case. What it does is a lot clever to pruning, if you look at it in the language of trees, in terms of the searches and everything, when it gets to the potential space solution, prunes the wrong ones and get to the solution much, well, it gets quicker because it gets to the right solution in one go, versus the classical computer have to try everything. So the gains on the computer comes from the interference. It doesn't come from there. And how to get started? Well, I leave there some books. As I said, the quantum computer book is quite good, but a bit harsh if your mathematics are not a bit out of scratch. But really beautiful book, for example, for quantum mechanics, something deeply in from Sean Carroll and Roger Penrose. This also does a lot of things. So yeah, so final point, and then we go to questions. You might get confused and say, well, I don't really understand what you're talking about. What you mean, cat dead and alive? Well, don't worry, nobody is very, very weird. And actually, this is a Nobel Prize, one of the best physicians we have, American. Nobody can tell you that understand this, because it's so not like our intuition work. And thank you very much. I'll leave to questions.
Thank you, Javier. Well, the question here is that I have is actually, we are talking about quantum computing for several decades, and you actually mentioned something about when we see, but when we see we can start using them widely. But can you speculate when we can start using them?
Thank you. That's a very, very good question. I mean, if you could have asked me 2 years ago when this is going to be ready, and I've been looking, I have 2 degrees, one of them is in quantum physics, in quantum fundamental physics. So I've been looking at this for a long time. I would have said we are still 5-10 years, because the engineering problems, I cannot stress how difficult, to achieve these things, the entanglement, the superposition, which you need to calculate to do the quantum calculations and the interference to all these things they need so precious and special conditions to scale this. And if you think about the current computers, they need to be at room temperature. They need to even have, be able to work and function at 30, 40 degrees. Is a massive, massive engineering project. So if you could have said 2 years, I could have said 5-10 years. But now is really incredible, and especially IBM is a bit earlier than expected. So now I will say maybe between 3 to 5 years, we might be able to see this thing. You only need 1 million qubits to start really being able to do practical things. And actually 3 years is a lot sooner than when you think about it. So we might start seeing this. You can already today run some quantum calculations on the cloud, but those are simulated, but you can get away. But in about 3 to 5 years, I think we will see these things commercially and being applied by, as I said, especially pharma. They're going to make massive value to the drug discovery and cycle. Today to develop certain drugs takes like a decade. By the time because all the interaction between the molecules are very difficult, so you have to do all the different tests how you can do the component, for example, designing antibiotics, and it takes a long time, and then you have to go to human trials. This thing can simulate the actual quantum system, so you could really, really compress. So this for medicine, it will be amazing, and that's why, as I said, the pharma is putting billions, out of all the money going into that, which I think this year there will be about between 50 and 100 billion. And know how much money is there is always difficult to calculate for many reasons. But this investment is not, this is not like something in a lab lock away. It's quite a big thing.
Okay, it's quite promising actually. So thank you very much. I hope you'll see you in a couple of years when you can give us an example using quantum computing. Thank you.
Thank you.
we created Indigo Design App Builder to accelerate your app delivery with one app creation platform. Now your designers, developers, and product managers can all work in the same WYSIWYG cloud-based platform. No need to download anything, no heavy IDEs or third-party dependencies, reducing friction and costly errors, and providing customers and users with better apps faster. Indigo Design App Builder includes a rich layout system and complete toolbox of real UI components and tools. Designers simply drag and drop actual components to build a real app fast, without the requirement of a vector-based design. With an integrated design system, you can easily create custom themes matching your product's branding. Get started quickly with a sketch file or use a pre-built app template. Deliver apps faster to your customers. Try Indigo Design App Builder today.
And our next speaker is Desi Andreeva. She is a software engineer at VMware and a passionate speaker at multiple conferences. Please welcome Desi on stage.
Thank you for the intro, Rado. Hello, everyone. Let me tell you first that life is full of consequences. Last week, at the same time, I presented in another forum, and I was trying to motivate people to go out of their comfort zones. So here I am doing exactly the same because I am the last-minute replacement of the initial presenter. Anyway, what am I going to talk about today? I will give you key ideas and paradigms that we used as basis of a solution for testing big data pipelines on our laptops without relying on any third-party additional tooling, which come with its price tag, of course. And most importantly, they could be kind of a closed source. Hope I could give you enough knowledge and encouragement so you could develop something like this yourself. Well, I mentioned big data, and because I know it's kind of a buzzword, I just wanted to be sure we are on the same page. So let's clear up what is a big data. Well, whenever I talk about it, imagine something and data that is so large, fast, and complex that it is difficult or impossible to process using the traditional data processing application software. I believe all of you at least once have worked with the traditional relational database management systems. They would most commonly consist of one very packed server, like with a lot of CPUs, SSDs, RAMs, and etc. And they would be more suitable for transactional processing systems. They can handle thousands of transactions and a lot of data modification queries, like update, delete, additions, and etc. But sometimes we have other use cases when working with data. We need to run complex and very expensive queries with a lot of aggregation, analytic functions, queries that require full table scans on tables having millions and billions of rows. So the traditional databases are not up to this task. And that is why for the past 10 years, to solve this problem, the distributed query engines were in development. Example of them you could see at the bottom right, like Hive, Spark, Presto, Flink, and etc. And they are distributed because the queries are executed over a cluster of nodes. We normally call them worker nodes. And each node is going to execute the query over a smaller subset of the data. And later on, the master node will combine the results for the final results. And why am I saying this? We have the solution for the problem, yes, but we are using these engines to build pipelines. And another problem appear, how are we going to test these pipelines? So let's take a look at an example. For simplicity, let's have a code base with one batch job that is written in Java, and we are going to leverage SQL to work with the data. This application will be deployed in the cloud with a CI/CD pipeline, and our job is going to be executed over a Spark cluster, which is basically what is basically Glue. We are going to work with 8 terabytes of data, which means that our job will execute for few hours. And because in the cloud we pay for the processing, we are going to have additional costs for that. Anyway, our job is going to prepare a report at the end, and we are going to expose the results in a dashboard, in a BI tool, like Tableau mode or whatever. So these dashboards and visualizations will be used by different stakeholders to take different business decisions. And imagine I am the developer of this bad job and I made a mistake in my SQL query. If I find a way to test this early on while I'm in the development, it is going to cost me only, depending on the problem with my query, only a few minutes to a few hours to fix this bug. Because I will modify the query, I will run my pipeline locally, and I will be able to fix it. But if I'm not able to test it locally and I need to deploy it somewhere in the cloud, in dev environment, for example, it is going to cost me again time, even additional time. So because I need to wait for the whole CI/CD pipeline to deploy my job somewhere in the cloud. But it is going to cost me money because, as I said, my job will run for a few hours and I will need to pay for this processing in the cloud. Anyway, how much is it going to cost me if I find the bug at the latest stage? Well, of course, all of these things that I already explained, they will be applicable for the later stage, but another possibility that could happen and another consequence is that this wrong data could be used by our stakeholders to make bad business decision. So we understand that the later we find the bugs, the more time consuming and the more costlier they become. And they could lead us to make bad business decisions. And we actually even can't estimate and predict how much this is going to cost for us. So having all of these in mind, we set different goals for our solution. We wanted it to be locally testable on the developer machine in the phase of when they're developing the pipeline. I explained why in the previous slide. We wanted to make our lives easier, so that's why in the perfect case, we wanted this solution to, we didn't want to make a lot of effort to set up our testing environment. So in the best case, the developer would only need to set up Java, install his favorite IDE, and then take the project, check out the project locally, and he will be good to go. Of course, we wanted our solution to be integratable with a CI/CD pipeline. We wanted it to be technology agnostic because we didn't want to tie to any specific provider or their technology stack. Our reasons are because if a new technology that is going to be better for us, like it would provide better processing or storage, we wanted to be able to migrate to that technology. And on the other hand, because requirements changes very, very quickly, we wanted to be able to migrate from on-prem to cloud and vice versa. So, and last but not least, we wanted our solution to be cost and time efficient, to help us very fastly and easily implement and test our pipelines locally, and to not generate additional cost when we want to scale. So having said all of those goals in mind, we started looking for the different options, and the natural first step was to look at the already existing solutions. One of the possibility was using local stack. It was going to meet some of our goals, like testing locally and automatically early in the development stage. We were going to have it very quickly up and running. However, this was going to bound us to Amazon. And this was not going to fit one of our goals, to be technology agnostic and migratable. And that was the biggest problem with the existing solutions, that they are emulating cloud-specific technologies and they do not target more than one service provider in their technology stack. So another reason we didn't choose the ready solution is because they do not always target the SQL pipeline. So for us, this meant that we needed to bootstrap additional services, and this come with additional cost. And the cost was going to increase the more we scale our solution. The more pipelines we have, even the more developers, because some of them are subscription-based, and the more users we have, the more we were going to pay. So obviously, this wasn't fitting to our goal to be cost efficient. So that's why, to meet all of our goals, we developed the so-called SQL library for running and unit testing SQL-driven workloads in an engine-agnostic way. To be able to achieve this, we based our solution in few very important key pillars. First of all, we needed to provide local emulation of the different analytical engines. This was going to give us the ability to test our solution over multiple engines in advance. And later on, if you want to migrate, this was going to happen without a lot of changes in our code base. Another thing, in our pipelines, very often we need to perform different file operations. So that's why different file operations, and our project and our pipelines were going to run in the production environment over a distributed file storage. But in order to be to work locally, we were going to use the local file system. So that's why we provided a common API to simulate all of the interactions that we would normally do in production over S3 or Azure locally. And last but not least, because we needed to provide, because we needed to execute a lot of queries over different multiple engines, we needed to provide a way to write engine agnostic SQLs. And of course, to be able to execute SQL queries, and each of these engines have different differences in these submissioning details. They use different protocols and different APIs. So we needed to think about that. Let's take a look first at the way we implemented the local emulation aspect. First of all, I know there's a lot of different technologies that you see here. I know how difficult it is to differentiate all of them, but like imagine each of them has, they all have similar functionalities and functions, but each of them is appropriate for different scenarios and need to perform better in different use cases. Just a quick example, Spark and Flink, they both support streaming and batch processing. But if I need to stream live data with a very low latency, I would most certainly use Flink. On the other hand, if I wanna perform batch processing and I don't have a requirement for the latency, I will choose Spark. Anyway, all of them has specifics, and we were able to emulate them in two different modes, embedded and external process mode. In embedded, we are leveraging Spark and Flink's local execution mode, and we run them as part of our application. Their clusters are running in the same JVM as separate threads. Anyway, we couldn't find a proper way to do that with Hive and Presto, so that's why we had the idea to store them as external processes in the operating system. And of course, this requires additional work like downloading the executables, storing them somewhere, the installation part, starting them in specific order, and for all of that is handled by our framework. So it is going to be very convenient for the developer to start them. He doesn't do anything. And we achieved all of these by only using Java, only setting Java on our machines. No additional software, no containers, and so on. So as I mentioned, we needed to be able to perform different file operations. Let me give you an example. We need to prepare file partitions, or sometimes we need to group files together so they could be registered as one table, and so on. So here you see a small subset of the different file operations that in general exist, but this is sufficient for us and for our needs when we implement our pipelines. And that's why we call it a minimal file system abstraction. And down here, you see the specific implementations. So whenever an URI schema is provided here, the framework is going to switch between the local or the production implementations. And in that way, we are providing for a developer, a common way to work with the file system without worrying for the, file specifics that he's working on. And last but not least, I mentioned that we needed to be able to execute queries, and not only that, but over different engines that have different submissioning details and have we use different protocols and APIs and etc. So that's why we have another abstraction about this. We are executing queries without results. And another thing that we need is to execute queries and store the results. So that's why we have an abstract representation of the result. Here again, you could see the specific implementations of this executor. For example, this one is going to use the JDBC protocol. This one is going to use directly Spark's job submission API to execute queries. This one could leverage the AWS client and so on. So whenever we choose an engine, we are going to switch between these different implementation. I mentioned engine agnostic queries. How do we achieve this? How were we able to write that type of queries? Well, we have another abstraction over the dialect specific for the different engines. And we have a templating mechanism. So we are able to write a template and later on to generate from that template SQL queries that would run perfectly over the different engines. So after having all of these bases provided by our framework, we needed to sit down and write our unit test, right? So to do this, we follow a few testing best practices. First of all, we are very careful when we are starting our engines because especially the ones I mentioned earlier where are started as a separate process, they could be very heavy and they could have long startup times because they require a lot of extra work. So whenever we are testing with them locally, we are having a test caching technique. We don't always, download them and install them and etc. We only do that whenever we have a newer version of them. Another thing is that sometimes it would be more than sufficient to test only against a few of the engines. So we don't need to initialize the other one. We are initializing only the ones we are using. Of course, our test should be atomic. Whenever a test is starting, they need to prepare all of the data, all of the tables and schemas that they need to perform their assertions. At the end, they need to clean up after them. And there shouldn't be a specific run ordering between the tests, and they shouldn't rely on each other. Of course, following all of these results may slow down a little bit the execution time, may lead to a repetition of work sometimes, but this is the only way we could deliver reliable results and consistent results. And this is the only way to find bugs very easily and very fast and very early on at the development stage. And we actually were, trying out different ways to improve our performance, and we found out that it is very useful to use a very minimum amount of data sets to perform the maximum coverage. So we are always very mindful of the data that we are using in our tests. So I will finish the presentation by going back at the different goals that we set and check on if we met all of them. So were we able to test locally, early in the development process, and without the hassle to do specific setups? Yes. Were we able to integrate our solution with a CI/CD pipelines? Yes, even without a click of a button, we are just pushing our code and it is tested automatically. Did we build a migratable and technology agnostic solution? Yes, our pipelines can work both in the cloud, on-premise, they're working locally over different engines and file systems. Were we cost and time efficient? Of course. Okay, I'm not going to, concentrate on the initial cost because, there was one to develop, to test this framework. But on the other hand, we experienced a lot of benefits from using a custom-made solution for us, because we could easily scale our solutions without additional cost. And it is help us very fastly and easily implement and test our pipelines locally. And as a bonus, we found out 2 additional benefits. First of all, by following the approach of testing very early on at the development phase, we minimize the need of a QA engineer who would go somewhere in the development environment and check on if we made some mistakes and then go on and fix them and etc. You remember the first slide. And the indication of that is that we haven't had a critical bug in the last year. So it's kind of an achievement. I hope this was enough to encourage you to develop a similar testing solution yourself. In the previous slides, I gave you a few starting points to start building your own DIY local stack without local stack. Thank you for attending the presentation.
Thank you, Desi. Actually, I have a question. Did you do deeper analysis of the cost and the comparison of the difference in the cost between building this in-house compared to the using a local stack, for example?
Well, actually, to be honest, we haven't done that. Because at first place, we never continued using local stack. At the beginning, we found, we find another path and build it our solution. But if I can, give a rough estimation, probably the cost of developing your own solution, first of all, to develop is fixed. So it is going to cost developers time and of course salaries to build it and test it. And of course, later on, small cost to maintain it. But in our case, the cost of maintaining this solution would probably not be so much because it's very simple and well done. But on the other hand, the cost of using a ready solution is not fixed, and it kind of depends on the size of the team and the counts of your pipelines, as I mentioned earlier. So I may be speculating here, but probably at the first year, in our case, having thinking about our pipelines and the size of our team, probably it was going to cost the same, but I think the difference of the cost would be visible at the second year when the second year for many reasons, like cost-wise. Because our solution increases, there are more people coming, and as I said, when you choose a paid one, this is going to be costly. So whenever you scale, but whenever you're using your custom made, the only cost you would pay is going to be, the maintaining this solution, which I don't believe is so much.
Okay, thank you very much. It was
you.
quite interesting, and I believe that a lot of people are going to try to implement it by themselves, or try to at least to evaluate the options available on the market and compare them for their use case. Thank you.
Thanks.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained.
The Hershey Company is an organization that's driven to bring positive impact to the world. We have in excess of 80 iconic brands such as Reese, Kit Kat, Hershey's. Hershey's looking at how do we evaluate and manage the brands that we are delivering to ensure that they're profitable. So technology will help to bring a lot of that together, whether it's through how we actually process certain types of transactions, whether it's how we evaluate and manage the financial performance of certain brands or certain customers. The organization was faced with making a decision and moving directly to adopt SAP S/4HANA Central Finance. We see it already leading to quicker decision making. We can do a lot of analysis on a brand, on a customer, on a specific cost center, as well as on vendor activity or customer activity. SAP was key to Hershey's overall success.
Smart IT е технологичното ядро за разработка и поддръжка на собствени комплексни бизнес решения на Management Financial Group. Български финансов холдинг в сферата на небанковите финансови услуги, опериращ в цяла Европа. Решенията, които Smart IT създава, подпомагат дигиталната трансформация на бизнеса. Днес звеното разполага с 130 специалисти, заети в разработката на ERP системи, бизнес интелидженс, финтех платформи и още. Дейността на компаниите се разделя в 5 дивизионни направления. Дивизия Home Collected Credits има най-голям дял от групата с общ оборот от близо 140 милиона евро за последната година, с представителства в Централна и Източна Европа.
Казвам се Радостин Богдан. В екипа на Smart IT съм от 6 години. Нашите партньори имат нужда от решения, които позволяват лесно, бързо и гъвкаво
Welcome back, everyone. You're watching Ista Conference 2021. My name is Konstantin Dinev, and I'm allowing my colleagues a well-deserved rest from moderator duty. The sessions so far have been exceptional on both streams, but Ista 2021 is not over yet. We're back for one last session, which is being broadcasted on both streams. The last session we have for you is our closing keynote, and the speaker delivering it needs no introduction. I'm certain that all of you are familiar with agile software development and use solid principles in your day-to-day work. Our speaker not only came up with these, but also made them a de facto standard when talking about software development processes and practices. Don't forget to post your questions to the speaker in the YouTube stream chat. And without further delay, I'm really excited to introduce to you Robert C. Martin, aka Uncle Bob. Welcome, Uncle Bob. Glad to have you with us.
It's good to be here. Thank you very much for inviting me. Should be a fun session. All right, everybody. This is a talk that I have given many times in many places over the last several years. It's called Expecting Professionalism. And it begins with a venture into a fantasy land where I have become your new Chief Technical Officer. This is probably not something you actually want because personally, I would not make a very good administrator. I'm a programmer, I like to code. But if I were your new CTO, then I would have certain expectations, certain things that I would expect that all of you would adhere to. And primarily, those things have to do with professionalism. I should say a word on this. First of all, are we professionals? Do we have a profession? What is a profession? What does it mean to have a profession? To have a profession means that there is something that you profess. There are rules, there are standards, there are ethics, there are disciplines that you profess. Do we have anything like that? Do we have standards that we all adhere to? Do we have a code of ethics that we all follow? Are there disciplines that we all use on a regular basis? Those are the trappings of a profession. Those are what help us to become professionals. Over the next hour, I'm going to be talking about some of those standards, ethics, and disciplines, and I'm going to phrase them in the language of expectations. What do I expect? What do customers expect? And what should you expect of yourself? Now, as I talk about these expectations, you will likely hear them with two ears. One of the ears will be the ear of the programmer. The other ear will be the ear of the customer and the user. The customer and the user's ear will hear something that makes perfect sense. These expectations are kind of obvious from the customer and the user's point of view. The programmer, on the other hand, will hear something that makes no sense at all. It will sound insane. That is how far our industry has departed from what customers and users expect. And so to begin, I expect a number of things. And here's the first thing I expect. I expect that we will not ship shit. Now, some of you out there probably have engaged in shipping shit. I certainly have in my past careers. I have been known from time to time to ship things that were rather smelly. This, unfortunately, has become relatively common. It is one of those bizarre situations where programmers now think that they must ship things with bugs. Now, consider, for example, how common it has become to ship the beta. A beta is something that you're supposed to give to a very small select group of trusted users. But we abandoned that, a decade or more ago. Now we just ship the beta. Hey guys, it's a beta. Try it. Everybody try it. If it crashes, well, remember, it's just a beta. We live in beta world now. Everything we ship is a beta. Oh, don't worry if it crashes, it's a beta. I use a piece of software when I'm flying my airplane, right? I've got a nice piece of software. It's written by some really spectacularly good software developers. This software is called ForeFlight. And I use it in the cockpit, and it's a lifesaver, quite literally, a lifesaver. It is very valuable software. Can you imagine if they said to me, oh yeah, we're shipping you the beta? those guys. So far, I have not seen any indication that they ship shit. They ship good stuff. We should expect that of ourselves as well. Certainly our customers expect that. Our customers and our managers and our users, when they receive our software, they expect that software is good software, right? It's a perfectly reasonable expectation. They do not expect that it will have bugs. They do not expect that it will have defects. Why should we? Let me ask you this question. Are you using a bug tracking system? Something like Jira. Are you using Jira to track your bugs? Or there's a bunch of other ones out there. I'm not trying to pick on Jira. Just there's a zillion little bug trackers out there. Bugzilla's another one. Tons of them. Ask yourself this question. Why do you need an automated database-driven system to keep track of your defects? Do you really have that many? Do you really have so many defects that you need to put them into a database, a megabyte database, and collate them and sort them using a computer? Why is it that the defects you have could not fit on, an index card? What? Couldn't you fit them all on an index card? Wouldn't that be, something that would be, expected by your users and your customers? Wouldn't they think, well, they should have, a couple of defects as long as it's not too many. So that's the first expectation, right? We will not ship shit. Now, already I've lost half the group right there because, the attitude is, well, we have to ship shit. How else could we meet our deadlines? Well, there's a problem there, isn't there? We're going to discuss that problem. But before we do, there's another expectation. I expect that we will always be ready. Now, what I mean by this is that we're all following the agile processes here. Maybe you're using Scrum, or maybe you're using extreme programming, or maybe you're using FDD or whatever, some agile process that you are using. Agile processes break the project up into time boxes, little time boxes. In Scrum, they're called sprints. In extreme programming, they're called iterations. Everybody has a different name for them, but they're all the same idea, right? They're a time box, and the normal duration for the time box is 2 weeks. I don't know what you're using. I hope it's about 2 weeks. Personally, I prefer 1 week. I think 1 week is better than 2 weeks. A lot can go wrong in 2 weeks. I kind of like to shorten that so that not so much goes wrong. I know in the early days, and now I'm talking 20 years ago, Scrum thought that the size of the sprint ought to be about 30 days. Then later on, they kind of shortened it down to 2 weeks. 2 weeks is very common now. What should be ready at the end of the sprint? What is the state of the software at the end of each sprint? And the answer to that is that the software is deployable. From a technical point of view, it is deployable. It may not be deployable from a business point of view, but from a technical point of view, it is deployable. Now, what that means is that if the business came to you and said, we're going to ship that software tomorrow, you would say, okay, it works. All QA is already signed off on it. All the features that we've implemented work just fine. All our tests passed. We've written all the documentation. So yeah, you want to ship it, go right ahead and ship it. That's the response from the development organization. The business may not want to deploy it because, well, it doesn't have enough features yet. For example, maybe log out is working, but log in is not working yet. The business probably doesn't want to deploy that just yet. But if they did, for some bizarre reason, we would say, fine, it works. Log out works great. If you've got some way that you can make money with a system that you can log out of but you can't log into, go for it, because log out works. That's the level of always being ready that I'm talking about. We, developers, do not put up roadblocks and say, no, you can't ship it. You can't ship it because it's full of defects. We've got to burn it in for months. Has anybody done this burn in thing? You know, you have, you take a month and you get the system set up and then you just watch it for like weeks. And you wonder, you know, I wonder if it's going to crash. And, you know, nobody's really using it. Maybe you've got some special users that are banging on it, or maybe you wrote some software that's pumping transactions into it or something, and you just kind of watch it and go, my God, is it going to work? Is it going to work? A burn-in sprint. Yeah. A stabilization sprint. Yeah, well. And then if it goes long enough and it doesn't crash, well, then you think, well, I guess it must be okay. I don't want any of those. I don't want those. No, at the end of every sprint, you should know. You should know that it works, and you should be confident that you can deploy it if the business says they want to deploy it. Deployment should be a business decision, not a technical decision. From a technical point of view, we are always ready to deploy. I expect stable productivity. Stable productivity. Now, what an interesting term, right? Imagine that you're on a team and this team is working on a greenfield project, right? It's a brand new project. There's no code. There's no code yet, right? It's brand new. You've got a list of requirements and, you know, people are coming to you and saying, can you do this feature? Can you get this feature written? And you think, my God, there's no code here. Yes, I can get this feature done. And you start to code and code pours out of every orifice of your body. And eventually you've got something working just in a matter of a week or two. You've got this feature working and everybody stands around and they're going, oh my God, they got the feature done in just a week or two. Why, I wonder if they can do that again. And they hand you another feature and you go, yes, we can get that done. Now you come back to that team about a year later. Ask them to do a feature. Ooh, I don't know, man. That's going to be tricky. Yeah, I think it's probably going to take us 3 or 4 months. But you used to do these kinds of things in a week. Yeah, but you don't know how complicated this system has become, how tangled, how interwoven. If we touch even one line of code, all hell could break loose. No, it's going to take us many months. I'm sure that some of you have had that experience. This is not stable productivity. Stable productivity is when the productivity you have today is roughly the same as the productivity you had a year ago, right? The software does not degrade. The software you are working on does not get worse and worse and worse with time. Instead, the software you are working on allows you to remain productive at a constant rate. I expect stable productivity. How are you going to get that stable productivity? I mean, customers expect that, right? They expect releases to come on a pretty regular basis, right? And they expect that the difference between the releases will be roughly the same. Oh, they got 7 new features in last time. They got 7 new features in this time. That's great. That's stable productivity. And that, by the way, that should not require that the staff increase by an order of magnitude every year, right? We should not have to add lots and lots and lots more programmers in order to get the same number of features in every year. That is what I expect. That's what managers would expect. That's what customers and users would expect. Stable productivity. I expect inexpensive adaptability. Inexpensive adaptability. Now, this is certainly what your users expect. You see, software is a compound word. It's made up of 2 words. The first word is soft, which means flexible. The second word is ware, which means product, software, flexible product. We intend that software systems are flexible. The reason software exists in the first place is that we wanted to have flexible machines. We wanted to be able to easily change the behavior of our machines. And therefore, if you write software that becomes hard to change, you have thwarted the very reason that software exists. If your architecture is so convoluted that no one can add new features anymore, well, then your architecture is pretty bad, isn't it? And it has thwarted the reason that software exists. Customers expect to be able to change. Now, they understand that the cost of a change is proportional to the scope of the change. If it's a big change, it should cost a lot. If it's a small change, it shouldn't cost very much. What really drives customers crazy is when they ask for what they consider to be a small change, and you come back and say, that ruins everything. Our architecture is going to be torn to shreds. It's going to take us man years of effort to do this little tiny thing. Yes, the customers don't like that. Customers expect inexpensive adaptability. They should be able to adapt the software. They should be able to ask for changes and pay commensurate with the scope. They should be able to pay a cost that is proportional to the scope. I expect continuous improvement, which means that everything should continuously improve. Everything should get better with time. What should get better with time? Well, the code. The code should get better with time. The design should get better with time. The architecture should get better with time. The feature set should get better with time. Everything should get better with time. The code should not degrade. The code should get better and better and better with time. You see, we are human beings, and human beings make things better with time. Theoretically speaking, of course, human beings make things better with time. That's what it means to be human. Software is not an exception to that. Our code should be getting better and better with time, not worse and worse. It should not be degrading. The system should not get more and more tangled and messy with time. It should get cleaner and cleaner with time. We should be constantly improving it. I have a rule. And the rule is I call it the Boy Scout rule. And the Boy Scout rule is that when you check the code in, you always check it in cleaner than you checked it out. Every single time, every single programmer. Check the code in cleaner than you checked it out. You know, it doesn't have to be a lot clean. It's just a little bit cleaner. As you're about to check the code in, do some random act of kindness to it just to make it a little bit better, and then check it in. Never check it in worse. Always check it in better. Just a little bit better. Imagine if everybody just did that. The code base would get better and better and better with time. Productivity would increase. Adaptability would become less and less expensive. If you simply cleaned the code a little bit every time you checked it in. Never, ever check it in worse. I expect fearless competence. Fearless competence. What does that mean? How many of you have brought code up on your screen and the code was horrible? And the blood drained from your face as you stared at this code and thought, oh my God, this is terrible. And a little whisper in your ear said, Well, you should clean it. And then the devil came and said, no, you must not clean it. Don't touch it, because if you touch it, you will break it. And if you break it, it becomes yours forever. And so you back away. You say, no, not me. I'm not going to be the one. I'm not going to be the one who tries to clean this code. No, because I don't want to own it. You've probably done this. I've done this. Everybody's done this. If you've been a programmer, you know exactly what I mean. This is a fear reaction. You have reacted in fear of the code that you created, the code that you and your companions created. You now fear it. You react to it with fear. I want you to think about that. I want you to think carefully about that, how wildly unprofessional that is, how deeply irresponsible it is to now fear the very thing you created, to have let it out of your control to the extent that you now fear it and have no control over it. You react to it. It does not react to you anymore. It now masters you. You used to be the master of all code, didn't you? You remember the day when you wrote your name in an infinite loop and you saw your name go up the screen and you thought, oh my God, the power. You felt like the master of the world. But now the code masters you. You are the slave. It is the master. This is not an acceptable outcome. Somehow, we're going to have to reclaim our competence, our fearless competence, because fearing the code is fearful incompetence. We want to become fearlessly competent. How could we do that? What could we do to make ourselves fearlessly competent? How can we conquer the fear? Imagine that you had a little button, just a little button. Maybe it's on your keyboard. And when you push that button, some lights would blink and some computer sounds would come out. And then a little green light would light up. And that little green light would tell you that the entire system works. Everything works. It's great. And you push that button and the green light lights up. Oh, it works. And the green light doesn't take very long to show up. Maybe 10 seconds, maybe 15, maybe 20 seconds. Ooh, push the button 20 seconds later. Green light. Everything works. Now, bring that code up on your screen. The horrible code. The code that makes the blood drain from your face. Bring that code up on your screen. You've got the button. The little thought in your ear says, well, you should clean it a little bit. And the devil can't speak because your next thought is, well, I could just change the name of that function. That function could have a better name. Push the button. Still green. Okay, I didn't break anything. I think I'm going to split that function in half. It's a little long. Split it into two functions. Give them both nice names. Hit the button. Oh, still green. Good. This function could really be in that class over there. I think I'm going to move it over there. Hit the button. Ooh, red. Ooh, put it back. Put it back. Put it back. Push the button. Green. I see what I did. I did it wrong. It belongs in this class over here. Push the button. Green. If you had that button, you would not fear the code. If you had that button, you would clean the code. If you cleaned the code, then you would be fearlessly competent. You would engage in inexpensive adaptability. You would continuously improve the product. Your productivity would be stable if you had that button. How do you get that button? Well, there is a discipline out there. Maybe you've heard of it. It's called test-driven development. And in test-driven development, just a little discipline, just a little thing that you do every minute. every second while you're programming and you're using test-driven development, you write a suite of tests in a very particular way, which I am not going to outline for you. You can look this up on your own if you'd like to. But you write yourself a suite of tests, and everybody else on the team continues to add to this suite of tests. And when you run that suite of tests, it tells you that there's nothing broken. And the discipline is such that the suite of tests you create is so complete that when that suite of tests passes, you know the system works. In fact, you know that you can deploy it. The suite of tests is the indication that you can deploy. Now, there are several things about this suite of tests that must be true. First, they must be very complete. That's one of the things that the discipline helps us with. It helps us to make the test suite complete. The next thing is that it must be fast. It must run quickly, a matter of a minute or 2 or 3 or 4, but not 20. Not even 10. 10 minutes is too long. 5 minutes is stretching it. The test should run pretty fast. And you think to yourself, well, it's impossible. We've got a really complicated system here. There's no way to test it in 5 minutes. Oh, yeah, there is. Consider it to be a design challenge. Put your design hat out and think, well, we got to finish the test in 3 minutes. How are we going to do that? You'll figure out a way, believe me. And I can prove that to you pretty quickly. How many instructions does your computer execute per second? Most computers nowadays, have 4 cores and they're executing at 2.6 gigahertz or something like that. So that would be on the order of 10 billion instructions per second. Does your program even have 10 billion instructions in it? I mean, even if it's 1 million lines of code long, I don't think you've got 10 billion instructions, which of course means that if you're going to test all 10 billion of those instructions, you should be able to execute those tests in less than a second. Unless, of course, you are executing some parts of the code more than once. Are you testing some parts of the code more than once? For example, let's say you write a test to test a business feature, and then you write another test to test a different business feature, and then you write a third test to test yet another business feature, and all 3 of those tests have to log into the system and have to navigate through the navigation hierarchy to get to the place where they can test that business rule. How many times do you have to test login to know that it works? Once, twice, just a couple of tests you need to run. You do not have to log in every single time. How many times do you have to test a database query to know that that database query works? 1 or 2 times, depending on the circumstances. How many times are you executing those database queries in your tests? Typically speaking, you can use reasonable design principles to reduce the number of times you execute the same code over and over and over again. So once again, consider that a design challenge and solve the problem of how long the tests take to run. Never accept the idea that the tests must require hours. No, they don't. You can speed them up. I expect extreme quality. I don't expect bugs. I don't expect defects. You shouldn't either. You shouldn't expect defects. Nothing should be going wrong. When the users get the code should work. What a concept. What a concept. When the users get the code should work. Well, what do you think of that? Now, how do you do that? Oh, you know what you do? You test it. You test the code. You, the programmer, you test the code. You make sure it works. And you write it cleanly, and you write it in a way that you can understand, and you get other people's eyes on it so that they can look at it and they can see that it works. You make sure it works. Do you have QA? Of course you have QA. Get QA involved. QA should be helping you to make sure that this software works properly. Now, I got things to say about QA. I'm going to talk about QA in just a minute, but I want to drive this point home first. Bugs are not acceptable. Bugs are not expected. The bug list should be short. It should fit on a card. right? It should not be in some database that you have to sort and collate. Think about that, right? You go to your users and say, our bug list has 10,000 bugs on it. It's really difficult to find anything in there. We've got to sort it and collate it all the time. If you want to put some more bugs in there, go right ahead. We'll never look at them because there's no way we're going to look at all those bugs ever. Yeah, that's not a great message to send to the users and customers, is it? So, more on QA. I expect that we will not dump on QA. Whose idea was it to put QA at the end of the project anyway? Who thought of that? Who's the person who said, what we need is a QA group, and we're going to put that QA group right at the end of the project, and we're going to give them all the crap, and then they're going to test it. Who thought of that? Why do we have QA in the first place? What motivated businesses to create a separate group of people to make sure that the code did what it's supposed to do? Why did they do that? And the answer to that should be obvious to you. They created a QA group because programmers were not doing what they were supposed to do. Programmers were letting everybody down. Programmers were shipping bad code. And so the QA groups were created, and the job of the QA groups is to test everything that the programmers did. Well, that's just nonsense, right? We don't want human beings testing everything that the programmers do. Programmers are smarter than that. That's not what we want QA to do. We do not want to dump on QA. We want QA. We do not want to dump on QA. We do not want to say, I think it probably works well enough to give to QA. No, you say it works. And you know what QA is going to find? QA will find nothing. That is your goal. QA should find nothing. I expect that QA will find nothing. In fact, I want QA to wonder why they're there. I want the quality assurance people to say, I don't even know why we're here. And by the way, I want to move them. I want to take them out of where they are. I don't want them at the end of the project. I want to use them where their talents would really be useful. I want to take the QA people and move them to the beginning of the project. I want the QA people specifying the system. I don't want them verifying the system. I want them specifying the system in detail. And I want those specifications automated. The QA folks and the business analysts should be writing a suite of automated acceptance tests. These tests, written in some very high-level specification language, not code, something like an Excel spreadsheet, something like that, a nice specification language. The QA people, the business analysts should be writing those tests, and the programmers should be automating those tests so that when the business wants to know if the software works as specified, the business just hits a button and the tests run and the little green light says, yep, it works as specified. I want two streams of tests. I want the tests that the QA and the business people write. I want the tests that the programmers write. And I want them both running every time anybody does anything. I want you to hit that button, and a few minutes later, the little green light lights up. And the little green light means that the system does everything the programmers expect it to do, and the system does everything the users and customers expect it to do. You see the slide here? The slide here, I took this picture in 2008. And the hands that you see are the hands of the QA manager. The document that he is holding out for me is the table of contents for his manual test plan. It is not his manual test plan. It is just the table of contents. He has 80,000 manual tests that he must run, and he must run them every 6 months. He sends that list over to an army of people in India, and it costs him $1 million every 6 months. He's holding this document out to me because the year is 2008, as I said, and the financial crisis has begun. And his boss has just gotten back from the CFO's office, and the CFO said everybody's budget is getting cut by 50%. And this QA manager just heard that his budget is getting cut by 50%. So he's holding this document out to me, and he's asking me this lovely question. Which half of these tests should I not run? And I told him, well, you can cut the document horizontally or vertically or depth-wise. It doesn't matter. You're not going to know if half your system works. That is the ultimate result of manual testing. Manual testing is insane. Manual testing, using human beings to test an automated system is insane. It's immoral. It's absurd. And every time you do it, every time you run manual tests, every time you make a manual testing the chief way to find out if the system works, you are going to lose those tests. And you will lose them in one of two ways. You will lose them either because somebody decides it's too expensive and they cut your budget, as happened to this poor guy, or there's a much more insidious way that you will lose the tests. The programmers deliver to QA, but they do not deliver on time. QA had budgeted a certain amount of time to run their manual tests. That time is now shortened. Does the release date move? Of course not. Release dates don't move. Therefore, the QA people are squeezed. They're the ones that have to absorb all of the late time. And they realize that they don't have time to run all the tests. So what do? Well, they do an impact analysis. They think, okay, what changed in this system? Okay, we'll only run those tests. This is a bad idea, right? Because what you know perfectly well, when you make changes to the code, it can break things that are all over the place. And if the QA people decide, well, we're only going to test the things that probably changed, they're going to get that wrong, and they're not going to execute critical tests. You will lose the tests if you test manually. The only way to make sure that you properly test the system is to automate as many of those tests as you can. And, we're programmers. That's what we do. We automate things, for God's sake. People will look at it and say, well, it's really expensive to automate all those tests. No, it's not expensive. It's expensive to have human beings run them. It's not comparatively speaking, it's not expensive to have programmers automate them. I mean, that is what we do, right? We automate things. I expect that the system will not be fragile. I expect that the system will be robust. I do not expect it to break a lot. I don't expect any particular parts of the system to be more fragile than other parts of the system. I expect that we will cover for each other. I expect that if one programmer goes down for some reason, goes on vacation or gets sick or quits and leaves, whatever reason, that other programmers will immediately be able to cover for it. I expect that you work together so closely that if someone leaves, all the other people around already know what that person is doing and can step in for them. There are disciplines that help with this. One of them is called pair programming. You may use that if you wish, or use some other technique, but make sure that if you go down, someone else can cover for you. I expect honest estimates. The most honest estimate you can give, of course, is I don't know. But that's not a useful estimate. So you're going to have to make it more useful by defining what you don't know. And the way you do that is by giving, one technique is to give three numbers, right? You say, someone says, well, how long is it going to take you to do this? And you say, well, if everything goes right, it'll take me about 5 days. Probably, though, it's going to be more like 10 days. And if everything goes wrong, it's going to be more like 30. Now, that's a perfectly fair way to characterize the estimate. Managers don't like that, of course, because they've got this range now. But the range is actually good because the range is the definition of what you don't know. The range describes your uncertainty, and that uncertainty is fair. So don't give them a number. Give them a range, and then continuously adjust that range as you know more and more and more. And say no if the answer is no. Someone says to you, I need this by Friday. If there's no way you're going to get it done by Friday, then you say, no, can't get it done by Friday. Sorry, no way, can't do it. And they say, well, you don't understand. It's got to be done by Friday. And you say, well, you don't understand. It's not going to be Friday. Sorry, no. You see, you were hired for your ability to say no because you are the one who knows. They're not. So you have to say no. You will save your company immense amounts of money if you say no at the right time. And be careful. There's a sneaky little way that people like you to get you to say yes. and it goes like this. Well, will you at least try? And your answer to that should be no, because you're already trying. How dare they suggest that you're not trying? Of course you're trying. Now, you probably don't want to yell. You probably don't want to stare at them and hurl insults at them. But imagine that, right? They're asking you at the end, well, will you at least try? Well, what do you think I've been doing? We've all been trying here. I mean, come on. The answer is no, because the answer is no. And with that, I think I will end this talk. Thank you for your attention. There's a few minutes left for questions and answers. So if you have questions, I'd be glad to hear them. And I might even be able to answer one or two.
Well, thank you very much, Uncle Bob. As always, your session is not only very informative, but it's a lot of fun. So we already have some questions that have come through chat. So the first one is from Radko. How do we execute longer tasks as sometimes a feature cannot be finished in 2 weeks, for example? How do you handle such cases to be release ready?
So this is a common question, and the answer always is you break that feature up into smaller features, which is always possible. It's always possible to do this because the job of a programmer is to break a feature down into individual lines of code. That's what we do. We break things down into smaller and smaller and smaller chunks until we're right down to an individual line of code. So what you have to do, if you've got a feature and you know this feature is going to take you more than 2 weeks, well, then you split it up into 2 or 3 or 5 features. And you promised, and you put those features into your iterations or your sprints. The business isn't going to like this. The business wants to think of the feature as a whole set. No, it's only one feature. Everything in this feature is just part of the main whole. But yeah, you can't do that. You can't let them do that. You're going to have to say, no, we really need to break this down into things that will fit in a 2-week time frame. And yes, what that means is that some of these features are going to be minimized until many other weeks have gone by. So, simple example, login. Everybody's got to have a login. Well, how do you define login? Well, I mean, the guy's going to enter their username and password. And if they enter their password wrong, we'll let them try 3 times. And if they fail on the 3rd try, we're going to disable their account for a day. And there will be a button at the bottom that says, remind me of my password, and we'll email something to them. And that will put them on a website where they can enter a special code that we send to them by text message. And that, okay, you get the idea, right? There's this really complicated feature that's called login. Well, I mean, the very first login you do, you could say to the business, the first login, it's just going to be username and password. That's it. None of these other things. Just use no 3 tries. No little button at the bottom, no disabling of the account, just username and password. It either succeeds or fails. And then a week later, maybe, we could add the 3 retries, and then maybe in the following sprint, we could put the little button down there. And I don't know how long it's going to take us to disable the account. We really haven't thought about that. We're going to probably want to estimate that one a little bit later, but, we can probably break it up and smear it out over 4 or 5 or 6 sprints. That is how you take advantage of that. Never let them bundle everything together and say, this is the feature, it's got to be done, and I don't want to hear about any intermediate features. No, you have to do it with intermediate features.
That was very thorough. So I have one question that I wanted to ask you. You said at the beginning, so don't ship the beta, right? That's one of the rules. But usually through these rules, you have to fight sales and sometimes, senior management, the business side of the company. So because of time to market, right? How do you deal with that?
Well, this is a really common question. Everybody wants to know, how do you face down managers who have their own set of constraints? Right? Now, the sales has a real problem, right? Marketing, they've got a real problem. They've got to solve that problem. And they're looking at the developers, they're looking at the technical team and hoping that the technical team has a solution to them. And maybe the technical team does, but maybe they don't. And you have to be able to tell them, no, sorry, we can't help you with this. There's just a certain set of physical laws here, and we cannot alter reality to meet your time frame or meet what you need. We're going to have to get creative and think of some different set of features or different set of behaviors that will at least satisfy part of your need, but we can't do this whole thing by the deadline that you're asking for. We can't. It's not going to happen. And if we try, we will fail. And if we fail, the whole enterprise fails. So let's not go down that path. I'm not trying to tell all the junior engineers in there that are listening to me here that you should roar around going, no, 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 no. That's not what I'm saying. But everybody should be looking for some way to achieve the goal. But for the senior people, the senior engineers, the senior developers, the people who have been at this for a decade, right? You are the ones who have the ability to go to management and say, look, this isn't possible. Sorry, it isn't possible. Now, let me give you a bit of advice here. We're programmers. We like dealing with machines. You and I did not get into this business because we like people. We like to fiddle with machines. We like to make machines work. So we are generally not good at confrontations, usually. Right? Usually a programmer is not someone who wants to get into a shouting match with his boss or her boss. Managers are different. Managers and salespeople, they like dealing with people. I know this is hard to imagine, right? But they like dealing with people. They like communicating with people, and they like the ability to manipulate and intimidate and use emotional force. An engineer finds the truth by observing and reasoning. That's what we do. Programmers do that. We observe and we reason. Managers and salespeople find the truth in a very different way. They find the truth emotionally. They get people to back down. So here's the scenario. Manager comes to you and says, I need it by Friday. And you say, I can't do it by Friday. And the manager says, you must do it by Friday. And you say, I can't do it by Friday. No, you must. You're not a team player. You're not helping me with this. And you, not wanting to go through this confrontation anymore, you start to say, well, maybe I could try. Now the manager has the truth, or at least in their perception, they have found the truth. Through a sequence of emotional manipulations, they got you to change your position, and now they know a truth. It may not be the truth, but from their point of view, they have learned that, oh yeah, if I push him hard enough, he's going to say yes. Be careful with this, right? You and I, programmers, we don't like this stuff, but we're going to have to get, I don't know that we'll ever get good at it, but we're going to have to get competent at it. We're going to have to be able to understand it for what it is, and then be able to stand our ground when it's really important to stand our ground. I had an experience many years ago. I was managing a group of programmers in England. And, managing, I was like the lead developer, but I was responsible for projects, and I talked to customers and things like that. And I had one particular customer who had a desperate need, and I got my resources arranged, and I promised this customer, yep, we can definitely deliver. And we could. I knew we could. And then I sat in a meeting with a bunch of other managers about a week later. And bit by bit, I saw them starting to steal my resources. They would say, well, we could use that guy here for this because it's more important than that other thing here. And one by one, these managers using this emotional manipulation technique would sit there and raid my team and start taking people and taking hours and taking time. And I realized that this promise I made to my customer was not going to happen. And I actually threw a fit. It's not something that I usually do, right? I usually don't start screaming. I don't get red-faced. I don't get emotional. But in this meeting, I just kind of lost it. And I said, you cannot do this, blah, blah, blah. And it was remarkable what happened. All these managers sat back in their chair and they said to me, well, you make a good point. Now, I had not made a point. I used no reasoning at all. All I did was yell at them, and they all go, oh, well, you've made a good point. And I learned something that day. Sometimes just standing your ground is the point.
Okay. Thank you very much for this advice. I think we have time for one or two more questions. So have Kalina from chat asking, but customers don't expect us to say no. They always expect to hear sure, no problem. How can we make them accept the reasonable no?
Well, you can't make anybody do anything, right? All you can do is make yourself do something. So if the answer is no, and you know that the answer is no, then you just have to stand your ground and say, no, it's not going to happen. Sorry. And does that mean you're going to lose your job? Are they going to fire you over this? They might. Okay. But they're going to fire you if you screw it up too. So you're kind of at a bad situation there. Maybe you think to yourself, well, at least I can keep my job for another month and then they'll fire me later because we didn't. But that's probably not a great way to handle it either. There is no way to make people do things. Now, what I would suggest, of course, is that you are ready with data. If you have data, if you know how fast your team can go, and by the way, how do you get that data? By measuring how much you get done in every sprint. That's part of the agile process, by the way. One of the reasons that we have sprints in Agile is so that we can measure how much we get done in each sprint. And then we can use that as historical data to go to managers and say, look, the last 10 sprints delivered this much. You're asking us to deliver 3 times that much in a lot less time. So the data doesn't support your ability to ask for that. If you have data, at least you can use the data to make the case. That does not guarantee that they will accept that data. I've certainly experienced managers who looked at the data and said, well, that data is baloney. Okay, what can I, all right, well, the answer is still no. Sorry, still can't do it. Do not expect people to be comfortable. They're not going to be comfortable because when you say no, that really hurts them. And they've got to figure out something else. It is your responsibility, however, as an engineer, to say no when the answer is no.
I think saying no is a pretty important message, throughout. I have one, it's actually a short question. The answer that you're going to give probably is not going to be so short, but what code coverage percentage is a good percentage? Range answers accepted too.
So I love this question. So yeah, what code coverage percentage is an appropriate percentage? Well, let me see there. If we were able to get like 80% code coverage, that would be pretty good, wouldn't it? That would only mean that 20% of the code doesn't work. There is no number other than 100%. There is no number other than 100%. The code coverage target is 100%. Of course it is. Now, can you get to 100%? Probably not. Think of it as an asymptotic goal, a goal that you are constantly pushing towards, never quite able to achieve. Sort of like, attaining your ideal weight. People aren't real good at that, asymptotically approaching the goal. But never settle for a number. 80% is not good enough. 90% is not good enough. 95% is not good enough. Only 100% is good enough. And even if you can't get to 100%, the effort must continue to drive it as high as you possibly can. Every little bit, notch it a little bit more, try to push it towards 100%.
Right. Yeah. That's what I thought you were going to say anyways, but we have one other one. What about changing the perspective? Humans make mistakes. Some tend to be lazy. Some tend to be too much optimistic, etc. Maybe I'm going to add a little bit on top of that. Like, what is, for example, the difference on how you deal with junior and senior engineers? Because you mentioned that in the previous answer. Is it different that you deal with younger teams and versus older teams, with the teams that have, more, I don't know, lazy engineers, too optimistic ones?
Okay, so replace the word engineer with doctor. Well, sometimes there's lazy doctors, sometimes there's incompetent doctors. Yeah, well, that's just the way things are. No. We need to be able to sort out very early on the lazy and incompetent people and make sure that they're not among our ranks, because we are the doctors. We are the ones who are responsible for the body of our companies. Software is the lifeblood of our companies. It is the lifeblood of our society right now, right? Society itself depends on software. Our civilization runs on software, and we are the doctors. So we had better be pretty competent. We had better not be lazy. We had better if there are lazy people in there, we probably need to give them other jobs, but not programming jobs, because there's way too much at stake. How should we relate between juniors and seniors? Well, one of the problems we have is that there are way too many juniors and not nearly enough seniors. And there are two reasons for that. One of them is that we try to take seniors and move them into management. That's probably not a good idea. We should probably keep these senior developers around for 15 or 20 or 25 years. The other reason is that the industry is growing so fast that the number of young people coming in completely outweighs the number of old people who are around. The number of programmers in the world doubles every 5 years or so. So that gives us this problem that we are in a perpetual state of inexperience. There are more young people coming in than there are old people to teach them. In a team of developers, you want to have some juniors, some middle, some senior, and you want to have a good ratio there, right? So you want to have some guys who have got 15 years experience, they've been around the block a bunch of times, they oversee some mid-level guys who have been around the block, 7 or 8 years, and then those people are the ones who oversee the juniors that are coming in right out of school. That kind of apprentice level kind of structure is what we all need. What we don't want is a team of 50 22-year-olds. That's not going to work. And we've seen how badly that does work in the past.
Yep, that makes complete sense. So we're out of time, and I really, really, really want to thank you for being with us this year. You know,
My pleasure.
Your presence here was amazing. So I would you know, wish you a good day. It's the beginning of the day for you, right?
Oh, yes, it is. It's about 11 o'clock in the morning.
Yeah, it's 7 p.m. already here. So, you know, we're going to close this.
Good evening to you.
Oh, thank you. So thank you once again. And I really hope that we're going to see you again in one of the next iterations of Ista.
Okay, next year, year after, something like that. Maybe it'll be live, huh?
That's what we're hoping. You know, that's what we've been hoping for the last 2 years. And you know, I'm so excited for all of the content that we were able to see today. As always, our goal is to deliver the highest quality sessions, and the speakers are what makes this event special, and they have once again delivered. We had to be online for the last 2 years, but we're hoping that 2022 is going to be a much better year for everyone, and that we'll be able to move back to the usual place where Ista is held. We can't wait to see all of you watching online back on site, networking and watching the event in the venue. Once again, I want to thank all of our partners that supported us to make Ista Conference 2021 a reality. I also have to give a big thanks to the 5 companies that are organizing this event. As with all good things, Ista 2021 comes to an end. We enjoyed every single minute of the 11th edition of Ista, and we're hoping, you know, that not only us here in the studio, but you, all of you watching online, have also felt the same way. We have plans to release content throughout the year in order to make your experience with Ista more continuous. So stay tuned for that. Follow us on social media. That was it from us. Goodbye. Thank you once again. I think we're